YouTube. Okay. Well, I am terribly sorry, everyone. We forgot to go live half an hour ago.
Oh no, we haven't been live?
We haven't been live.
Oh well, a good practice.
It was good practice. I am terribly sorry, everybody. We had thought everything was going okay, and I checked over, and I forgot to go live at when we started. So
30 minutes behind.
only 30 minutes. I am terribly, terribly sorry for everybody still waiting. I feel horrible about it.
We appreciate you waiting though.
Yes, so we can do the quick version. Welcome belatedly to the Fort Worth Astronomical Society's virtual star party for September 11th. I'm Chris Moynitsky, your host, and we have as our co-host. So we've been talking for about half an hour or so, and
Quite a conversation.
yeah. Okay, we had some issues. We worked through them. We're at the point now where we can actually do something, which is nice. So also, we do have currently a actual in-person star party going on at Tandy Hills in Fort Worth, Texas. It is located just to the east of downtown Fort Worth. If you look where the antennas are that are broadcast hill there, that's where Tandy Hills is. So it is a natural area, and we have a number of telescopes out there. So, yeah, I'm terribly sorry about that. But I guess we can go on right now. Man, I just feel bad. All right, what are we looking at right now? We are currently looking at the moon, and it is fairly low in the sky. We have just under a half moon. It's a fairly thick crescent right now. So if I zoom out all the way, get back to about there or so, this is what we're looking at. We can actually see some color in the moon. With this camera, what we can see is some of the mare are darker, they're more brownish than others. Part of this actually may be because of the sky. Our sky is rather covered over in in smoke. We have smoke coming from fires out west, so it is affecting our seeing. It's not terribly transparent today. It's clear, it's just not transparent. What that means is there's that haze in the atmosphere, and that's keeping us from really doing any really good observing. But we're going to try to get as much done as we can tonight. We're going to be here for a while, an extra half an hour since we started a half hour late. Terribly sorry. And yeah, we're going to go from there. So right now we're looking at the moon. George is just about. Are you ready?
I still have to do my polar alignment. But
Okay.
I'm 5 out of 2 points.
Cool. So just a few minutes off, and we're going to be looking at the moon here. I've redone it. So when we're looking at a crescent moon, actually, you know what? Before we do that, I got to see if I can get the focus good, or better than what we got. So this is what we're looking at here. I've got other software, and I'm trying to get focus assistant. Well, yeah. I was using the focuser yesterday, and I don't know why I can't see it today. I will try one more thing. So I'm going to bring it back up on the moon here. I'm going to zoom out while y'all take a look. Nice view of the moon. We can see the mare here. You can see the craters along the terminator. What we're seeing here is this is a we'll just zoom in on this one. We'll just redo that one. So what we're looking at here is a crater on the edge of the terminator. What we can see is this lip of the crater is lit up. The sun is streaming over the lip to light up the inside of the far lip of the crater. And right in the middle is the rebound mountain. And that is, just the very top of that is getting lit up by sunlight. If we look a little bit further down here, we see another crater where the rebound mountain is lit up, and we can see right behind it here, we can see the shadow. There is the shadow right there. And I will zoom in even further on that one so it's more visible. I think I got the focus pretty decent, but I want to play with it some more. There we go. All right, how much can we go? 1,000%, something like that. I really zoomed in there now. So this is actually the atmosphere. The atmosphere is causing some refraction, and it's not looking terribly great, but that's okay. So we can see the lip of the crater here. We can see the shadow cast by the lip. Right there is the rebound mountain that's being lit up. And right behind it, we can see the shadow of the rebound mountain. And then this is the far lip that's being lit up. And the bottom here is in shadow. And on some of these craters, for example, if you were on this one, if you were standing right in the middle of this crater, because the moon is so much smaller than the Earth, the curvature is so much greater that you could be standing in the middle and you would not be able to see the crater walls around you. It would look like you were in just on flat ground. But if you went higher, if you were on a rocket right in the middle and you took off in the rocket, the higher you go, you would begin to see the tops of the craters, the crater rim rise above the edge, and you'd be able to see that you were actually in a crater. And that is just physics. We're going out. We can see some rills through here, some cliffs that are being lit up, some mountains. Yeah, so these are mountains. Just the very, very tops of the mountains are being lit up by the sun, just barely. So this is all in twilight. Well, see, on Earth you would call it twilight because the sun can be below the horizon and it's lighting up. It's still the light is still hitting the atmosphere above you, so that will then refract and light up the ground. So the sun can set and it's still a little bit bright. That's not the case on the moon. It's pretty much quite literally black and white. Once the sun is below the horizon, it is dark. As soon as it pops up above the horizon, it starts to light up everything around. But the moment it crosses the horizon and goes down, that's it. That's sunset. You really can't tell the difference between 5 minutes after sunset and a week after sunset. Because remember, the moon goes around at the same time that it goes around the Earth. So a full day's rotation on the moon takes 29 point whatever days. Almost a full month to go around. So the a moon's daytime at any given place on the moon, day lasts for just over 2 weeks, and then night lasts just over 2 weeks. So it's nice and slow, which is good. In some ways, it's bad. Power from solar power is hard to deal with when your days are that long and your nights are that long. But if we could put a telescope on the moon, that'd be absolutely fantastic because we would be able to have very long nights to do some very nice observing. But we can't do that right now. How are you doing, George? Okay. All right. Mine isn't quite staying in the same spot. So that's okay. We're going to do this. We're going to see select and slew. We're going to go see if we can find Venus. Jupiter, Mars, Venus. Should be close.
Huh?
Should be close. I'm just hoping I'm not shooting through my car. Oh, there's Venus. Cool. All right, and I can do everything from the controller right here. Wrong direction. Down. Go. 4 over. There we go. All right. Let's see what Venus looks like. I have no idea what Venus looks like, other than the fact that it's low to the ground. Why are there bugs crawling on me? All right. Yep, that's Venus. I'm not terribly impressed because it's low in the sky, but we can make out it is not exactly round. It's kind of gibbous. So if it was fully round, it'd be like this. But it is probably on the far side of the sun. So if it's on the far side, it's going to be gibbous, and we can tell. Oh, come on. Really? Yeah, this isn't going to work at all. This I have to get on. Wow. Yeah, I'm not too happy. I've had equipment issues today, and I don't think I can hit the focuser very well. That's okay. George, you got something to show off yet?
No, I think it's rolled up.
Don't.
Polar line.
Yeah, and I'm there we go. There's something. Yeah, we're just having issues today, aren't we? But that's okay. If you have any questions, you can go ahead and put them in the chat. And I'm looking at them right now, so we will be able to see what's going on. It is warm, but it should be actually cool. I think tonight's supposed to be down to 63 degrees here in Texas, and because we're out in the country, it should drop down a little bit more, so it might be 60 degrees come morning. So the summer may be going away, which is strange for Texas. It's also rather dry, so we got to drink just water. All right. I'm trying. Somebody left me a bungee cord. I know who left me a bungee cord. Okay. George is still getting ready. Yeah. So I'm going to say menu, sync. Well, I got to do this. X out. How close am I to center? Good enough. Sync to target. Sync successful. All right. George can switch over soon enough. I will switch to a different camera. Okay. That's all right. What else can we look at right now? You know what? Ring Nebula. Let's go to Ring. So menu, I'm going to go select and slew. We're going to deep sky, named objects. And we're going to go to Ring Nebula. Why Ring Nebula? Because Ring Nebula is overhead, and while the camera is still got power, we're going to use it. I don't know how good of a picture we'll be able to get, but we will see. Ring Nebula. So the Ring Nebula is a this is a planetary nebula, and what a planetary nebula is, when a star like our sun gets old, it starts to blow off its outer layers. Well, first it becomes a red giant. When it stops being able to burn hydrogen because it's all run out. Helium is what's left over. So hydrogen fusion stops, the star collapses, fusion of helium starts, and then the star expands out again, and it turns into a red giant. And it goes through these pulses, and as these pulses happen for hydrogen, for lithium, for carbon, nitrogen, depending on how big it is, it keeps pulsing out, and these pulses throw out material. The outer layers of the sun just get blown out until all that's left is a little white dwarf. The white dwarf is just the core of the star that's left over. It's not fusing. It is literally just radiating pent-up heat. Nothing else. So that little bitty core is now glowing. It's white hot, very, very hot, and it's throwing off a lot of ultraviolet radiation. That ultraviolet radiation is now causing all the gases that got thrown out to fluoresce. So we have hydrogen gas, we have oxygen gas, we have sulfur, a little bit of nitrogen sometimes, and then all those different gases give off different colors when they're irradiated by ultraviolet light. And so that's what we're going to be looking at. So to do that, we have to do some imaging. we can't just go ahead and take a picture, or we can't do live views because it is so dim. And let's do I'm gonna do a 30-second exposure just so we can see what we're looking at. 1600 ISO. Nah, let's blast that. I'm gonna go pretty high up. And so we're gonna do a 30-second exposure. So it'll take a 30-second exposure, and then it'll take another 30-second exposure as a dark frame, because this is a Canon, and we can do that. So it'll be a minute for an exposure, it'll download it, and then we'll be able to see what we're looking at. Are we actually looking at the ring? Are we close to it? If not, well, we gotta get closer. So just a little bit more. It should be okay. Should be fine. All right. Again, if you have any questions, put them in the chat. Bugs. Not a mosquito. That was something else. Yeah, we have lights here. So if you have lights with the laptops, with the studio lights, it's going to attract bugs. I think last year, last summer out here, at one point, the entire table was covered in bugs. They were crawling on the monitors. They were crawling on me. Not the most fun nights. Let's see. George, I don't think I can. Uh-oh.
What?
I can barely hear you, so I don't think I have your microphone turned on. I gotta grab that. Yeah. Nobody, well, kind of. All right. George, say something.
Testing, 1, 2, 3.
There we go. Now we got George.
There we
Okay.
go.
So this is way blown out. Is it blown out enough that I can't see anything?
Is that the moon?
No.
Oh.
I'm trying to do the ring. Let's just do a 10-second exposure. Yeah, this is way blown out. A 30-second exposure at that ISO just blew everything out. So we're going to cut down the ISO and cut down the time so we can just see something. We should be able to see something. Right now, this is a 11-inch Celestron Schmidt Cassegrain. It is nominally an f10. For an 11-inch, that's a whole lot of focal length. But I have it as an f6.3 with the adapter. So that should let us get a bit wider field than we would normally. And we're looking at, I don't even know. What are we looking at? We're looking at not the ring. I don't see the ring anywhere in here. I do not see the ring. All right, we're going to say goodbye to the ring. Not worry about the ring. We're going to jump over instead to Jupiter. No, we're going to do Saturn first.
I see Saturn over there, Jupiter back there.
Yep.
Back there.
So Saturn is a little bit higher. We're going to jump to Saturn.
And you'll probably get a better read on that since the sky's so murky tonight.
Yeah. Well, I should be able to pick up the ring. I really should, but
I was going to try the helix if it were.
Solar system objects, and we're going to go to Saturn. So we're looking at planetary, bulb, aperture, ISO. Good. All right, that's going. That's going. Okay. I got to keep track of everything on here. Yeah, it's just like
You're
I
going to
said.
have to let me rework your wiring harnesses.
Do what? Which ones?
All of them.
What, yours or mine?
on your deal there.
It's fine. It's good. All right, I see something. I don't know what that is. I don't have a clue. Bulb is fine. ISO is fine. There's something right there. I have no idea what that is. I'm pretty sure this is not pointed at Saturn. So I'm going to have to redo it.
Uh-oh.
One moment.
Accelerate time.
Oh, yeah, that's why I've got it. I can see anything.
We have visitor. It always looks good when you're doing astronomy. Especially if you're a nerd. No.
Do I have anything?
Anybody that plays with their TV and does video games, or even does any technology. If they can change the clock from flashing 12 to the actual time, they're a nerd.
I can't see. I'm looking at Saturn. I just cannot see it through the reticle. There it is. Is that close?
Is that a live view image?
I'm doing it live on there. Trying to.
Huh.
Not making it easy. I mean, I can.
Yeah, I dropped my my focal length down from 1155 to about 800 with a reducer on mine, so that I could do some bigger objects. I got a good portion of the Andromeda Galaxy. There it is. Nope.
No, that's the finder. I swear I'm looking right at it.
Huh. You look like you're right about on it. Come on, Scope. Do me
Is that
good.
close? I have no idea. All right, let's switch to Jupiter.
Jupiter's brighter, so you should be able to get it.
Yeah. Good. Good.
We're doing lucky imaging. If we can get it, it's lucky.
I'm way off of everything. I'm totally way off of everything. I'm nowhere near anything. There's Jupiter. Jupiter's really obvious.
Is your finder lined up with everything?
I'm not even using the finder. I'm using a Rigel Quick Find, and that one's good. Menu, sync to target. Sync successful, but it's just not. It's not where I want it to be.
Huh.
All right, so what are you looking at? We're looking at Jupiter. Okay.
The Jovian Giant.
Yep. It's big. It's nice.
I saw a pretty picture of the northern pole on Jupiter, and it actually had some hexagonal. It was like a dance of hurricanes around the central portion of the north pole.
Of Jupiter, though?
Yeah, it was gorgeous. You could see the magnetic flux and how it was lighting up that central area on the pole. And then all the way around that pole were like huge hurricanes.
Wait a minute, what are we looking at? What are we looking at? There we go. We got banding. We got some banding of Jupiter right there.
The four-legged kind.
Oh yeah, we've got cats out here. We got dogs out here. There are coyotes. There are cows next door.
So we don't have to worry about mice or...
No. No. The water moccasins and the copperheads take care of the mice.
Yeah, tastes like chicken. Uh-oh.
I believe that would be one of the dogs.
I don't think so.
It's a cat?
That's a cat making that noise.
Oh. I don't know.
They're having a cat fight.
It's something. All right, so we got some banding on Jupiter. I really want to fix the focuser. You know what? I'm going to do this. I've got an idea about what's going on.
Actually, that's not bad.
What? Jupiter?
The actual picture there. I don't see the... Oh, you're gonna...
Yeah, I gotta take this. I'm going to. Sorry, I have to unplug
That's
USB cable because my focuser apparently doesn't want to work with my switch. So I have to use.
Okay, now I can do polar alignment.
Yeah. Technical issues. I swear I'm going to build an observatory so I don't have to mess with this.
Huh? Wow.
What do you got?
Oh, I've got to tighten my right knob 6 full turns.
Cats. Okay. Let's see if I can get this thing. No, it doesn't like this. ASCOM. Maybe it's device hub again. No? Focuser. Not letting me connect to it, and I don't know why. Maybe I'll try again. Connect the focuser. Alright, so we got Jupiter. It's swimming. Zoom in more. I think I would have to play with the
Oh, that's
focus.
way below. Okay, I don't want to do that one.
This isn't letting me focus
Let's
it.
try Antares.
Let's see if I can get this. Oh, device. Device manager. We're going to try this again. See if I can get... If I should be able to see a... COM port 4. Yeah. That's the right one. It's the right one because I was using it yesterday. For some reason, I just can't focus. It's just super, super annoying. Tools. Yeah. I swear, it's there's always something. All right, so we're looking at Jupiter. What are we looking for, though? We want to zoom out. Specifically, what I want to do is this. What we're going to do is take shutter speed. We're going to punch it. I'm going to slow it down quite a bit because I want to see those moons. So one of the issues with doing stuff like this is we can see either Jupiter well or we can see the moons well. But that's it. The moons are not badly out of focus. Not too bad. I think you can probably crank it down a little bit more. But again, it's getting the focus. Where is it? Where is it? Where is it? I'll have to close that. It's just strange. I know I was focusing yesterday just fine. I just don't remember ASCOM Platform 6. Maybe. Focus controller? No. ASCOM Focus Simulator. Yeah, there's all this stuff. Celestron. No.
Almost there.
No. The astrophotography tool? No. There's so much software. I just can't remember. I just can't remember what I was using. And at the same time, it's figuring out. Oh, here we go. ASCOM Focuser. Maybe. That was it. That was it. Celestron USB Focuser. I believe that's it. Properties. Yes. Comport 4. Okay. 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 Yes. All right. Cool. All right, here's what we're going to do. This is how we electronically focus. There we go. Okay, we're going to focus. We're going to focus on the moons of Jupiter. How? Like this. We're going to come in about 1,000%. Going to look at that guy. And that guy. I'm going to step it. And we're going to do what the optometrist says. Is it better like this or like this? Like this or like this? Let's go 10. Is it better? Is it worse? Well, that's objectively worse. Back the other direction. Better? It's getting better. 71's pretty good. 81's not bad. 91? That's not too bad. So there should be like a focusing assistant on here. Let's do frame and focus, I believe is what it is. Yeah. So we're going to come down. Double click to unlock. Come down to here. And then we're going to zoom in on that one. There we go. That's what I want to see right there. Okay. So how good of a focus is that? I don't know. .8. We're trying to get that graph. Is that what we're trying to do? Peak that graph or what? Or get that number as low as possible? See, that's just bad. We can see that's bad. That's gone too far. 61, 31. We'll try to get that number as low as possible, I think. So we were down to what? 3.9, 3.8, 3.9, back up to 4. Okay, so we want 51, 61, 71. Like that way too much? 4.0 is where we were.
Very cool. Okay.
A1.
Now,
Somewhere in that range. Somewhere in that range, that's about as focused as we're going to get. So let's take a look at Jupiter. We're doing bulb duration. Yeah, let's get that down again. I want to see what Jupiter looks like when we drop it down. A lot more? 20? There it goes. You good, George?
polar line and filtered up.
Okay. Yeah, so right there on Jupiter, we've got, yeah, this is a DSLR. It's not really meant for what we're trying to do with it. So I want to recenter this thing just a tad and say, okay, a little bit over and a little bit down. And now I'm going to resync it. Menu, target. Sync successful. So this should be pointed at Jupiter now, but not yet. So we can see 3 of the moons. That's absolutely correct. And I'm... Starry Night Pro is not working. I will have to kill it. Yeah, I'm gonna have to kill it, kill the process, and start it up again. Starry Night Pro. We'll get the earlier version. All right, down for that. And Starry Night. I actually have 2 monitors on here. On the laptop. So my streaming setup right now, I've got a camera on for George and myself. I've got a microphone for George and myself, and then I have the streaming computer, and I also have my astronomical laptop, and my astronomical laptop actually has a extra monitor off to the side. So again, feels just like work. I'm just surrounded with monitors.
Unfortunately, that's the case, right?
Yeah, you can never get away from it.
No.
All right, so I've got that thing going. The Starry Night is starting up again. We're going to go back to planetary. Let's take a look at Jupiter again. So again, when we're looking at Jupiter, oops, when we're looking at Jupiter itself, either we can see Jupiter or we can see the moons. So in this case, we can see some of the banding, and because I got the DSLR on there, it's not going to take great images of the planets. It just won't. But we either see Jupiter or we see the moons. And so it's going to blow out Jupiter, but it will let us see 1, 2, 3 moons, 1, 2, and then a third moon down here that will zoom out. So these are the Galileans. I don't know which one's which yet. There we go. We're going to find Jupiter. So this is Starry Night. And we're going to view, label the planets and moons. Make it easy. Oh, we can see Pluto, which, well, I've tried to see Pluto. Pluto is really, really hard to get. We're actually at 3RF a couple weeks ago trying to see Pluto. It's just really hard. Shadow of Io. Oh, we should be able to see Io and the shadow of Io on the very, very edge. Unfortunately, it ain't good enough. So Io is right there. Select Jupiter's center out Jupiter. What are we looking at? We're looking at Europa, Ganymede, and Callisto. And then Io is right on top of Jupiter, but it's just, and the shadow of Io should be there on the edge. It's just, let's see if we can pick it out. Because why not? I think if I switch to a different camera, I should be able to pick it out better.
That's it right there.
Yeah. I don't see the shadow. I don't see Io. We need a different camera. This one, I think the pixels are just too large. Looking at the moon under my light. It's really, really red right now. You good?
I am going to the Veil Nebula.
Oh, okay.
See what we can get on it.
All right. So, George, I'm going to switch over to your camera. How's that?
You may do so, sir.
All right. Okay, so this is what George is looking at. And I'm going to make sure... Oh, I got to add George's microphone to here, too. Add audio capture.
Take a 1/22 exposure.
There we go. So, George, what software are you using?
Right now, I'm using the base SkyX software, which is proprietary to Software Bisque, but it also works with other mounts, and it does the full gambit. Controls the camera, the guiding, the rotator, the focuser, the mount. So basically, everything and anything that has to do with this mount over here, it does. It does have a limitation in the fact that it doesn't do automation. So you can't just basically set up a nice little set of deals going, and it's not going to let you go to sleep, basically, which I like to do. So I also have something on here called Voyager, which is made by a small Italian company. Phenomenal software. It does a lot of stuff that is quite amazing in that it senses when something's going wrong and tries to adapt to it or recover from it. But yeah, when I do stuff at night in my backyard and I know it's not going to be raining or doing any crazy stuff like it's been doing lately, which kind of makes me worry a lot nowadays. I'll just go to bed after I set it up, and it'll take pictures of anything and everything I want in the backyard, or at star parties for that matter. But yeah, we're doing a 122nd exposure of the, I believe it's called the Western Veil. Might be the Witch's Broom. We'll see when it pops up here. I just put in Veil Nebula, and it picks the most well-known object and goes to it.
I'm trying to find where some of my adapters are.
Uh-oh.
My tubes. Oh, I know roughly where they are. I just got to go find them.
So we'll see how it looks. If it doesn't look good in this, I'll switch over to, oh, there we go. That doesn't look bad at all. Let me adjust some stuff here. Make it so it's a little bit brighter. Heuristic.
Looks okay?
It's not bad.
Okay. Have to...
I set the highlights a little too high. It makes it grainier, so I don't want to do that as much. Scale, let's try that a little bit more.
All right, so I need power, and I need USB 3 cable, which is, this one is too short. Right.
So that's a 122nd exposure of the
oh wow,
the Witch's Broom.
That's very nice.
Through an L Pro filter, which is a very good light pollution type filter that is generic. You can use it on galaxies, on nebulas, a whole plethora of objects out there, because it's not as restrictive. It's not as narrowband, so it'll let a lot of the light through. It does block the the regular lights, the street lamps and such like that. It doesn't do as good a job on LEDs, but then again, there's not a whole lot out there that will these days because it's so broad spectrum. But yeah, 120 seconds on the Veil Nebula. Let's take a look and see what we can see on some other stuff out there. Get this back to where it's a normal size. There we go. And then I'll look up. And just for your thing here, I'm looking at a list that I made last night of objects that would be in the sky tonight, and we'll just kind of go through some of them and take a look and see what we can see. So on this one, we'll do Pac-Man Nebula, see if we can do that. And it finds it, and
I'm going to get rid of that.
we'll do Closed Loop Slew, which is a plate-solving slew. It'll get there, it'll take a picture, figure out where it is in relation to the object, and then adjust the mount to point correctly to that object. That's the first picture. It's moving it. And there you go. Now it is right on it. So let's go back to the camera. We'll take another, let's bop this up and see if we can get a little better image.
All right, I've got to refocus.
Let's see, 20 plus 60, 80. So let's do that. Let's see what we can do on a 3-minute image.
Where did my focuser go? I just literally, did my focuser disconnect?
So yeah, what I'll do right now is it's, as you can see on the screen, it's basically just going to be taking a 3-minute picture. And let's see, where's it pointing at? We're pointing away from the lights, so it should get a fairly decent picture of this. It's lower on the horizon than the veil was, but heck, we'll try for it. Because transparency is kind of tonight, it probably won't be as good as it could be, but it'll be something. And the telescope we're using tonight is a 165 millimeter ED telescope. It's the top of the line one that Explorer Scientific makes, and it's made from FPL 53 glass, which is the best in the world. Phenomenal telescope. I just kind of lucked into it. Thank you. Thanks to my friend over there that had one laying around that he wasn't using. We did a little bit of bartering and trading, and that is where I got it from.
Oh, now I'm connected. Okay. Yeah, good times.
So it was fun.
Okay, so I need...
It's an exercise in
utility.
problem solving. Every time you go out
Utility.
in the field. That's why you see everybody with a cargo trailer full of parts and stuff, because they don't want to get out there and have to realize that they can't take pretty pictures or look at the objects that they want to look at.
Yeah,
So
one of the
bring
worst
seconds
things...
of everything. Cables and parts and such like that.
One of the worst things is to be out a couple of hours away from home.
I drove 2 hours out here and I forgot my stinking USB cable. Now I can't do anything. I have to go home again.
It's that one USB cable you desperately need. And it's always that way.
Yeah. I don't know if I have that picture on my laptop or not, but when I went to the Texas Star Party last time with my wife in 2019, it was stuffed. And I even had a hitch mount platform in the back with more stuff. I've got a little Transit Connect, which has, it's like the inside of the TARDIS. It's huge inside, but looks small on the outside. All right, we're getting there. 88, 89%. Time goes slower when you're waiting.
Oh, I got a much better image now.
It sounds like you're getting there with the
motor
focuser.
Yeah, I've got 100 steps now.
98.
So
here comes drum roll.
I'm gonna blow it out so I can see the
that's
moons.
nasty. Let me
Go to
clean
the
that
moons.
up.
Yeah, and of course I forgot my bat mouth mask. So because of course I did.
Did I
So
get anything?
instead,
Oh, I see a little bit of red in there. That's the one thing about this software that I don't think it could be better, is that its Fitzviewer is not as good as some of the ones out there that I've seen. Let's see.
The thing about this is,
I see it. It's
if
right
you're
there.
doing this visually, it's relatively easy.
Yeah.
It really is. When instead you're trying to do this as astrophotography, you're trying to get it as close as you can, as perfect as you can, and it ain't.
No, it's not. Okay.
You're close. You're always so close. It's like, and with the Batenoff basket, this would be like stupid easy. And of course, I forgot it. And what a Batenoff mask is, it's the easy way to describe them. Okay, so you can put,
Visual aid,
yeah, that. Okay.
if you can see it.
Yeah, so what that is a, it's a screen that goes over the front of your telescope. And what happens is, as the light passes through, it actually diffracts, and it creates a pattern on the screen. So what you're seeing is, when you're looking at a point source of light, like a star, you see the star-shaped pattern. It's think of it, it's 6 spikes. No, it won't.
Buggers.
Yeah. I've got an 8-inch one as well. I've got one for that, and I forgot it yesterday. And this morning I was saying, "Don't forget it, don't forget it, don't forget it." And this afternoon I was saying, "Don't forget it, don't forget it, don't forget it." I forgot it.
You never win.
Yeah.
All right.
I know exactly where it is. I just forgot it. Okay, so while you're doing that,
M33.
I'm looking at the moons
Oh,
of
it's way
Jupiter, and yeah, that's about as focused as I can get, and I was actually pretty good right there.
Let's see. NGC 6946. Oh, we got a
That's not too bad. Okay, so
mantis
I
over
switched to a
here.
different camera, and this is a dedicated astronomical camera.
6946.
So we're seeing moons of Jupiter there, and this one, here's Jupiter right there. And this is blown out. It's way blown out because I'm taking 400 milliseconds. Instead, let's just do that. 2 milliseconds, almost 6 milliseconds, a little bit brighter. 10 milliseconds. All right. So we can zoom in quite a bit more. Toho. And what I really want is raw 8. I don't want raw 8. I want raw 16. I want more colors. It's going to be a bit slower. RGB 24. I haven't messed with RGB 24 lately. Okay. So I can bring this down just a tad and play with the gain. Drop the gain way down. I will expose it for a bit longer. And this is all just playing with it, seeing what we got. I don't want it too overexposed, but there we go. That's not too bad. Not too bad at all. We can see some of the banding. I can't see Io on here. Oh, there it is. Hold on. Right there. At the top, there is Io's shadow. It's that little dark area right through there. Just to the left of where the mouse is, it's a little shadow. Not that easy to see, but I think I actually got it. And this is not the best of cameras. You know what? Let's do this. Let's just do auto gain. Whatever my gain needs to be. And then I will drop this down. Now it's starting to pop up. I will make this a little bit faster. Let's pop the gain up. Auto gain. Maybe a little more. Yeah, we can actually see something. Yeah. That's a bit too much. See what that does. There is a dark spot up there at the very top that's just consistently there. Yeah, I'm gonna have to drop my gain down. Okay, that's not too bad. But we can see there's a spot that's consistently in this area right here. The atmosphere is it's just not playing nicely today. I can actually smell the smoke in the air, can you?
Yeah, a little bit, yeah.
Yeah. So, it oh, dinosaur fell off.
Little praying mantises zipping around here, which are kind of cool, but you don't really want them jumping on your face and doing kind of things, do you?
Not necessarily. Also, I'm covering up my water because I don't want any bugs in there either.
Bug flavored water. Mm.
So we got Jupiter here.
I'm
This
doing the Fireworks Galaxy to see if I can get anything out of it. If that doesn't pull through, I'll do M13, which is
okay.
a really nice cluster.
So we can see the banding in Jupiter. We can see shadow of Io. And I'm going to bring up
That is a nice picture.
Starry Night again. So Io is crossing, and we have Io shadow in transit. I want to see how good yours is, your camera. So when you're done with that,
It might be fairly decent, but I'm not going to get a very good image because I'm only at 800 focal length.
Might get something.
I mean, you're shooting natively probably without any focal reducer.
No, it is a focal reducer. I can take the focal reducer off.
Yeah.
That may help. That may actually help.
So what are you getting? 1600?
Something like that.
Okay.
So we can see the shadow, and the shadow's actually moved a bit. When we started, it was right there on the edge, and now it's moved off right there. So yeah, let's do that. I'm gonna say auto. It's off to the edge. We're gonna do this. We're gonna do that, and I'm gonna say, okay, that moves down, that moves up. I've got the hand controller in my hand. I have to figure out which direction is what direction for me moving it. A little bit slower. That's close. A little bit up. A little bit up. A little bit up. And the reason why I want it centered out, now I do menu, sync to target, yet again, sync successful. So we have it centered. I'm going to go back. I'm going to have to get the focal reducer off of it. And then we're going to go magnify as much as we can with what we got. Okay. So, lights on.
Lights on. Lights off.
Oh boy. Oh yeah. I velcroed cables to this thing. I have to undo them. That's fine. Okay. No, I'm going to switch over to George because mine is not going to be terribly interesting while I do
fine.
this.
You'll see what I get out of this from 10-second photo. Let's see what we get.
Okay.
It's blown out, but you can see the moons and everything.
Maybe I should take this thing out first.
Let's see if we can do a half a second exposure. See what we get. That's a 10-second exposure. That's half a second. Zero 5. Let's do 5 100ths. Five 1,000ths. Wow, that's a bright object.
Looks good.
1 1,000th. All right.
All right. What do I got now? I have nothing. I got nothing. Nothing at all.
I don't know that I can go any lower than that.
Oh yeah, I do. There it is. Okay, so I've got this huge blown out Jupiter. You looking at Jupiter too?
I just finished watching that series.
All right, mine is grossly blown out. So I'm gonna have to refocus completely.
Okay, that's what I get when I expose it at like 1 1,000th of a second and really crop it in.
Yeah, I think it's It's the pixel size. So I've got a camera just for planetary.
Yeah, mine's 3.76, which is extremely small for planetary. I think you want bigger, don't you?
No, you want smaller.
Do you?
Yeah, planetary you want as tiny as possible.
Well, this is probably one of the smallest pixels, but it's just like, I think the focal length, because if you do, here's what it looks like with, wait, let me get it out too. That's what it looks like when I don't have any cropping.
Yep.
So basically it's a dot, and if I crop it in, you can see the bands, but you're not going to see a whole lot else. If I didn't have the focal reducer on it, and that would be a major operation in itself just to replace that with the spacer rings, you would see this probably a little bit better.
I just overstepped mine somewhere, so I have to bring mine down. Jeez.
I'll go see something that I can actually.
Oh, that's pretty good right there. I have to
Hold on.
recenter it. Wrong way. Oh, jeez. Do 2. Man, it's gonna be so. Yeah. I have to be super, super careful because my magnification on this thing is absolutely ridiculous.
Right now, yeah.
But Jupiter looks good. It looks better than with the focal reducer. Oh wow, this is gonna be pretty decent. All right.
The closer you can get to that thing, and the less lensing you have between you and it is better.
So we're gonna take this off, and now I can do zoom in on it. Oh yeah, this is much better. Focusing isn't that great, but yeah, I'm gonna see if I can. I gotta get better focus.
Yeah. So right now I'm taking a picture of the Great Globular Cluster in Hercules M13, which on this scope should look fairly decent.
Oh yeah. I went past again.
Yeah, a lot of the stuff that you guys see when you look through a Dobsonian or an eyepiece is going to be greenish or just a blob or a blurb. I mean, you're not going to see a whole lot of detail. The bigger the scope, the better when you're doing eyepiece, and the darker the skies, the better. So if you get somebody that is a friend or know somebody that has like a 30-inch Dobsonian and they're out in the middle of nowhere and you go out and look through their eyepiece, you're probably going to see quite a bit.
It's kind of like a boat.
Yeah.
You want to borrow a friend's boat. You don't necessarily want to have a boat that big yourself.
Nope.
Because if you have a 30-inch Dob, that means you also have a trailer. If you have a trailer, that means you have a truck. And a 30-inch Dob in town isn't really worth it.
No, it isn't.
It's much better to take it someplace dark. We're going to switch back over to me. And now I have a much better view of Jupiter. And now we can actually see the shadow of Io
very
popping up
nice.
there. It's not fantastic, but it's at least visible. And it's definitely there. It's definitely there. And so Io should be right about here somewhere. It's hard to see. I think it's that little blob right there, actually. I think that's it right about there. If we bring up Starry Night, maybe a little bit closer. So we have Io shadow there. We have Io close to the center line. Let's go back. So maybe Io, that's probably Io right there. Not up here, right about there. And again, it's really hard to see because we don't really have fantastic resolution. We don't really have, I mean, let's face it, Io is pretty much the same color as Jupiter. Maybe a little bit more saturated. But it's going to be really close, and it's going to be hard to see. And that's something that is typical. Sometimes with a really good telescope, with really good eyes, you can make it out. With the camera, not so much. But we are able to see Jupiter pretty well. We are able to see the shadow of Io. Now, here's the thing. I'm doing 19, almost 20 millisecond exposures. I can make it a little bit faster, and hopefully the gain will kick in. See if the gain will kick in now. A little bit. A little bit. 10. So the faster I can take the exposures, the smoother the image is going to be. But tonight is just not great seeing. We've had much better seeing in the past. I'm going to bring it up to almost 20 milliseconds again. Let the gain take it. You can see a little bit better right there. But yeah, it's not terribly great viewing. I know my focus is a little bit off. I know it's a little bit off. You know what? Let's see if we can make the focus a little better. I'm going to pump up my time so we're grossly blown out. And see, where are those moons? Where are those moons? There they are. So you can see right now, we can only see one of the moons. The rest of them are off the scale of this sensor. So that's not horrible. Let's see what I can do for focusing it a little bit better. Oh, that's worse. It's a tad bit better. I'm trying to get it as small as possible. And I think I actually have a focusing aid, focus assistant. Contrast aid detection. Let's see what that's like. I have no idea what this is. I've never done it this way. So if I go move in. Yeah. No idea. Not a clue. Let's get rid of this one and check out one of the others. And I'm going to do... See, I don't have fat enough mask. No pixels above the black level. Nope. I'm trying. So tools again, focus assistant, and we're going to go... let's look at the histogram. Going to be picking this up? Not really. Not a whole lot that's doing. I think I need to go back. Oops. 221, 225. I think it's going to get too much better than that. The seeing's not fantastic. Yeah. George, what do you think about the seeing? I'm not terribly impressed.
I mean, I'm looking at a red moon, so it's awful.
Yeah.
But yeah, it's a night out. Normally on nights like this, if it weren't bad seeing, we'd be doing some imaging, but this kind of night is good for knocking the cobwebs out of the equipment, making sure everything's working, and
playing around.
Setting it up for next time.
If you have any questions, go ahead and put them in the chat. I am watching this time. So that's going. And yeah, so we're looking at, this is, which one is this? Europa. We're looking at the moon of Jupiter. This is Europa. So
Wow.
We're going to come back out. I don't think I'm going to be able to focus any better. Instead, we have a big, bright Jupiter. Let's cut this back down. 19. There we go. And let's zoom in some more. So if I do auto, that's the size of Jupiter on the sensor itself. There is a, well, this one doesn't have it, does it? Hardware binning. I don't want to do any binning. Yeah, it's not really what I want to mess with, but that's okay. No, I don't want to do TIFFs. Definitely not do TIFFs. Oh, SCR. So if I was recording this, what I could actually do is just record, just keep recording, and then I can do what's called lucky pixel imaging, or lucky frame imaging. And what it'll do is it'll actually pull out just the good frames, and it'll ignore all the rest. So every time it gets just sharp enough, it'll keep that one. Wherever it's not that good looking, we'll just toss it out. The advantage of that is now I have a set of really good images, and I can stack those, and I can generate an image which is relatively clear. Right now, It's wobbly. You can see the edge of Jupiter's just really wavy. It's coming in and out of focus. Sometimes you can see the dark spot right there, um, the shadow of Io. Sometimes it almost goes away, and sometimes it's pretty dark. It's really obvious. Like right now, that's good. And now it's kind of going away. And now it's really good. And now it's good. And that's the lucky imaging. But at least we are able to see Jupiter. That's actually pretty cool. I think if it was if it was just a better night, if we had better seeing, better upper atmospheric conditions, it'd look a lot nicer. This is really as good as we're going to get it right now. That was a pretty good one. Yeah, some of these are coming in pretty well. So with visual observing, it's kind of the same thing. You sit in front of your telescope and you look at it, and you look at it, and you look at it, and sometimes you can be looking at the same object for an hour, especially for planets. And what you're waiting for is a couple of seconds of really, really good seeing when um, when it just grabs it just right. And at that point, that's what you're waiting for. So everything clears out, just crystal clear for just a few moments, and then it all goes away again. So that's kind of what we're doing here. We're waiting for those few frames that look good, where we can see the banding come in clear, the shadow of Io. Oh, excuse me. So yeah, Io should be right about here now. If we look at Starry Night, you can see Io is almost at the midline, right there, right across the middle. And I do not see the great red spot is coming around the edge, coming very much so around the edge. I don't think we'll be able to make it out very well, at least not for a while, not for a couple of hours. But the great red spot is right over here. I'm gonna go a little bit over. Here we go. And a bit down. The great red spot is coming around on this side, and this is the shadow of Io on Jupiter, and Io should be right about here somewhere. And again, it's the same color. It's just going to blend in. Same thing with all the other moons. I think sometimes if you have a really good telescope, really sharp objects, sharp optics, and it's just a good night for seeing, then you can actually make out a one of the moons crossing the face of Jupiter. But not right at this moment. That's not too bad though.
And they actually make a device called an atmospheric disturbance corrector that you can place on your telescope that will compensate somewhat for the atmospheric, wobble.
Yep. And there's also they're called active optics. And what it is a little bitty glass window. It's just a small little glass window, and it has little actuators that move it in different directions. And it's got a little pick-off mirror. The pick-off mirror sends the image to a sensor, which processes it and sends. You have the application on your computer, and it sends back the signal, so it will actually move that little piece of glass, that optical window. I think like 100 times a second or more, just a little bitty tiny bit, but very, very quickly. And it is specifically intended to stabilize atmospheres. They're not cheap, and I haven't seen any new ones. I know SBIG used to have one a while back, but I don't know if anyone does the. I'm pretty sure somebody does adaptive optics now. I'm just drawing a blank as to who, because I don't have any, and I haven't been shopping for any because they're rather expensive. But they can really, really help stabilize your images. So what I always found funny is that we have this atmospheric wobble just really messing up planetary images, and you can really see it changing it this much. But then you take pictures of stars, and your optics are open for, a minute, 5 minutes, 10 minutes, depending on some objects, and you don't necessarily see that wobble. because it kind of averages itself all out, unless the atmosphere is really unstable, and then all your stars are streaked. Nothing looks good. So I'm going to try something on here as well. So I've got PhD. So PhD stands for Push Here Dummy. It is a neat little program, and what it will do is let me connect to my camera, and that's the one I want. Connect. And close. What I should be able to do is this. Ah, there we go. This is basically my electronic finder. So there is Jupiter. A 2-second exposure. I do not want a 2-second exposure. I want a 1-second exposure. But in this one, actually, I could go with less. There we go. So what we're seeing is Jupiter and 3 of its moons right there and a couple stars around. So over here, what I'm going to do is guiding. Is it going to guide? Is it going to work? I don't know. So I'm looking at my graph. And what this does is, oh, it's not going to be guiding. Yep. I'm going to stop it. Yep. Keep that. Grab that star. And this time it said shift click to force calibration. Let's do that. Oh, shift click. Ah. I did control click instead. So we're going to grab that. Shift click. There we go. Okay, so what I'm doing right now with PhD, if you haven't used it before, if you don't know what it is, Push Here Dummy is a neat little program that lets me go ahead and control the mount and tell the mount what to do. And the reason why it's called Push Here Dummy is because the signals that it sends back to the mount basically say, if the star starts to drift in this direction, push it back. If it starts to drift in this direction, push it back. Goes down, push it back up. It goes up, push it back down. Keep it right here. And that's all that does. So it sends push commands to the mount just to move it a tiny amount. So the calibration process is training it. George doesn't have to do this. He's got a big, fancy, expensive mount. So all he does is train his mount, and then he can do unguided exposures, where his mount knows where everything is now, so it can be super accurate. I think I can do that with mine as well.
Yeah, you can pack train yours.
Yeah, I'm just lazy about it. I don't want to mess with it.
Depends on how much you want to dink with guiding.
That's exactly it. And it's how much effort I want to put into it. And right now, all my effort, when I actually have time to do anything, I try to do star parties. I really haven't done any imaging for myself. I take that back. I did 3RF last month, and yeah, about a month ago, and it was really nice. It was super dark. If you don't know, 3RF is the Three Rivers Foundation. This is out past Crowell, Texas. Basically, from the Dallas-Fort Worth Metroplex, you take 287 out towards Amarillo, and it is halfway between Fort Worth and Amarillo, roughly. And you head to, you exit at Vernon, then you head to Crowell, and then you keep going till you're in the middle of nowhere. Then you hang a left, and then you keep going. That's the easiest way to describe it. But you can actually look it up. It's 3rf.org. They have an astronomical campus out there. They have a number of very large telescopes. They built some very lovely cabins to rent and stay the night, or technically for astronomers, to spend the day, because we are up all night looking at stuff, and then we sleep during the day. So that was actually quite nice, and the sky was quite dark, and we could see pretty well. Oh, I got a bug on my screen now. So Jupiter, again, we have Io crossing quite nicely, and that is the shadow of Io. And the great red spot should be coming around right about here. So back to Starry Night. Oops. Io has crossed the meridian. So it is past the center mark, and the shadow just keeps going. And the great red spot is going as well. That is pretty neat. I didn't even realize we'd be catching that today. Actually, when I talk to George, I should be looking down like this and talking to George this way.
Yeah.
That's the way it is on the camera. George is actually located about 15 feet in that direction from me. It is getting a little bit chilly, though, isn't it?
It's getting nice compared to what we've been dealing with,
well,
which is
yes.
80, 90 degrees at night. Yeah, this is nice.
All right. George, you got something to show off or not yet?
I have M13 up and running.
All right. Let's switch it back to George. There we go.
All right, so this is basically 120-second exposure of M13. And I'm using a color camera, which is, neither here nor there. Some people like to use monochrome, some use color. I use both. I use monochrome when I want to do very high definition, very contrasty looking photos, because the sensor is, I can't say it's more sensitive, but it is utilizing the entire sensor rather than just one of every 4-bit or one of every 4 pixels on the sensor, which is what we're doing here with the color camera. The thing that is appealing for the color camera is, one, you get a fully colorized image if you've got a software package that allows you to do debayering. And two is if you don't have a lot of time to do the imaging, because a lot of the monochrome stuff requires that you take multiple images of the same object using different filters. So I have sodium, sulfur 2, oxygen 3, and H alpha filter. Those are the narrowband filters, and you have to take the same or equivalent numbers of the different bands, and then you combine them all, and that creates a very rich looking image. But that usually takes anywhere from 6 to 20 plus hours. I've seen people that take 50, 60, 100 hours to do a single object in the sky, just because they want to get that much detail in it. But for what we're doing tonight, when we're doing the quick picks, the color camera works really well. And as you can see, we've got several different stars in here that have different colorations, and that's their natural color. You're seeing a natural color. I'm not processing this in any way, shape, or form to look this way. This is what the camera is actually seeing. And the only reason that you're not seeing it like this when you're looking through an eyepiece is because I'm storing the photons on the pixel side, and it makes the image a little bit brighter so that you can see the colors. That's probably because of the noise in the sky. Yeah, like I said, it doesn't have the greatest of fits viewers, which is what it does. It basically takes a picture and puts it into what it perceives it as. And the fits viewer for this particular software, the SkyX, is okay if you're just looking at objects, wanting to see that you're getting something, but it's not as finely done up as some of the professional stuff. So. Or some of, I can't say professional. This is a professional software package, but it's not as nice looking as some of the camera manufacturer software, like the ASI software that they have out there for their specific cameras. So yeah, it is a little washed out. You can see it's a little grainy around the sides. What you're seeing in the middle of the picture is a globular cluster, which means that all those little dots that you're seeing there are suns, similar to our own sun, and they're just packed into a very tight area. This is there's a lot of them out there. This is one of the ones that we see a lot of because it is so big and so prominent in our sky. But you can see this in a telescope. If you look in a telescope, you'll see a very similar image. It just won't be as well defined.
Sorry, I had a cat. Yep, that's it. I had a cat. He jumped up on the table.
Yes,
So
we have a lot of cats.
that's one of the
That's
issues
okay though.
with-
We like cats. Cats keep the mice away.
Yep. So we're out in the country. We're out in Grandview, Texas. Not even in town in Grandview, Texas. We're off on the more rural side of Grandview. So we've got dogs, we got cats, we got cows next door, and I think they're mostly asleep by now. And we got coyotes. So the coyotes will be out later as well.
And I'm going to try something. I can use the SkyX to do my stuff, or I can actually use
You don't use SharpCap?
ASI Studio, which has a live stacking capability.
Oh, okay.
So
Yeah,
I
why
can
not?
attach my camera. I don't want the 174. I want the 2600 because that's my main camera.
So while you're
Attach it.
doing that, I'm going to try to swing over on Saturn. I have no idea how well this is going to work.
Go for it.
All right, menu.
Gain high. Keep the binning where it is. Ooh, I don't like the gain high. I like it low.
I see it. Barely see it. Okay. No, I mean it's there. It's actually quite nice.
You talking about Saturn?
Yeah. It's not bad. Yeah, I gotta play with it. I gotta get obviously much more exposure. The bright. Oh, that's not bad. It's not great, but it's not bad. Yeah, you can't see it yet. I haven't switched over to it.
Okay. Yeah, what I'm trying right now is live stacking, which is basically taking pictures and the machine will, as it's taking them, stack one on top of the other so that you get a more defined image. We'll see how that does after it does it several times.
All right, so we'll see how. I'll switch over to mine. All right, so this is PhD again. So we're tracking on something. This is Saturn here, and we're basically using this thing as our electronic viewfinder. And we're going to switch over to SharpCap. Now we got Saturn. And every once in a while, when it comes in, we can see the Cassini division. This is black gap right here. And then again on here, it's a gap between the rings. We can actually see right back here, that little notch. This is the shadow of Saturn back on the rings. So in its position, this is the sunlit side, this edge, and this is the twilight side, that edge right there. And we got that little notch from the shadow of Saturn onto the rings. It's not too bad. It ain't fantastic, but it's not too bad. And we can see some of the banding. I'm going to cut down just a little bit on the exposure. Slow it down just a tad. So it's a little bit darker. I probably need to go a little bit higher. 50 should be fine. I have to check the phone.
You know, another reason why mine's probably not displaying it in all its glory is because I'm using a headless PC, which is what you're seeing the image from here, inside of a box that has everything. I basically can take my box with me and hook it to my telescope and mount, and everything's in the box that I need to make it work. But it doesn't have the greatest graphics cards.
That'll do too. So a lot of the stuff nowadays, it's better than it used to be. The cameras are better. The electronics are so much faster. The pixels are smaller, so the resolution is higher. We can do more easily. I've got little bitty monitors. They're little LCDs, um, super thin and really bright, really nice. We can actually use them. I've got an extra one. My my extra monitors are better than the monitor on the laptop. um, and it just makes everything so much easier. Everything is smaller. It takes less to pack. I can say that 10 years ago, um, you would pack a laptop and you wouldn't be able to pack anything more. You wouldn't bring a second monitor. You definitely wouldn't bring another computer. You just bring an extra laptop and do everything off the laptop. Now, you can actually travel with a lot more. And they also make small computers that literally fit on top of your telescope. ASI makes two different models. It's one is a Raspberry Pi, and the other one it's something else. Is it a souped up Raspberry Pi or is it something else?
Raspberry Pi is used in a lot of astronomy stuff. You're talking
Yeah,
about the ASI Air
yeah.
or the ASI Air
The
Plus or
the
Pro or
Air,
whatever?
the Air. I think I don't remember what the Air Plus does, but the ASI Air. It's a Raspberry Pi. It's a standard Raspberry Pi 3, um, and all it has is their software on it, um, onto a little micro SD card, and everything runs from there. It will control their cameras. It will control your telescope. It will do the auto guiding. It will do plate solving. It will do everything that you need it to do on a little box, um, a little bit smaller than my phone, and a little bit as thick as two or three of my phones. And you can actually just Velcro it to your telescope and plug everything in there, and then you control it from a tablet. Um, you it has its own little Wi-Fi, so you connect to it from your tablet or your phone, and you do everything that way. Um, you record it to like a USB hard drive that you connect to it. Everything's fine. I'm not at that point yet that I want to do something that minimal, um, especially if I'm going to be do streaming. If I do streaming, I can't do anything that small. I have to do this because you really can't see what's going on a tiny monitor if I try to stream that out. This is really nice though because I can go ahead and stream it. It is going out. If there are any issues with the stream, if it's kind of wonky, let me know in the chat. Just go ahead and put that in. If you have any questions, if there's any specific objects you want to see tonight, let us know and we'll do that. George, you got that live view going?
I had it going on M13. I switched over to the Helix, but it cannot find anything over there as far as stars. So
Okay. So we're
let me
still
pop
on
it over to another
Saturn.
object and I'll look at it.
I'm gonna do this. Before we do that, I'm gonna jump over to Saturn because I want to see. We're still on Jupiter. I want to see if we can see. Yep, wrong button. So I'm gonna go to Saturn. The reason is I want to see what moons are on Saturn. Swinging over. We got lots of stuff over there. So we should be able to see a bunch of moons all around. Titan should be nearby. We should see them all in the field of view. But we need a much longer exposure. So let's do that. And then I'm going to zoom out. So Saturn's nicely blown out. There we go. Got Titan right there. Let's make a longer exposure. There we go. There's Titan. That was some others. There we go. Something else is popping. Ah, there we go. Now we got some moons of Saturn. A little bit longer exposure. Let's get a 3-second exposure so we can pull out. There we go. Now they're coming out. Okay, so I'm going to take Starry Night. I'm going to grab Starry Night. I'm going to actually put it on the other monitor so that I can tell which one's which. Really? No, that's not what I wanted. That's what I wanted. Okay. So we're looking at this would be Titan. because it's big and it's bright. The biggest one out there is going to be Titan. Off to the side, we have Tethys and Rhea. Here, Epimetheus, and that would be Dione. Yeah, Dione. That looks about right, yeah. So I'm going to see if we can do a little bit longer of an exposure, LX mode. Oh, yes. Yes. Probably need a raw 16. 6 seconds. Come in. There it goes. Yeah, that's a little bit better. That looks like it's just a star up here. I will double check. Yes. Oh, wait, what is that? That is just a star. That is Tycho 6338-1473-1. It is just a star. Wow. That is pretty neat. We were able to see some more. Let's get, let's push it. I want to get 13-second exposure. Let's see just how much we can see. And down there at the bottom, you can see I had the frame coming in. All right. It is now 10:01. That's not too bad. All right, we're not picking anything. Oh, yeah, we are. Picking a little bit more out. Let's zoom in. Oh, man. These are just hot pixels. I'm not worried about those at all. So it just looks like it's something it's not. So let's bring it back to 200. Yeah, these are hot pixels. That's a hot pixel. That's a hot pixel. Image artifacts. I don't care about those. What I care about is anything more visible. There is something visible right here. This would probably be Calypso. That thing right there, that's probably Calypso, but it's hard. It's really hard to tell. There's so much that's lost in here. Lost in the haze, so to speak. You'd think there was something up here, but there's not. Not according to this. See, it's a little bit stretched out. It's fine. This is Dione right there. Or Enceladus? No, this looks like it could be Enceladus. It's a Dione or Enceladus. Let's see which one's brighter. Enceladus. Yeah. Yep. Dione is going to be slightly out here. This is Enceladus here. Yeah, Enceladus. Tethys. Rhea. And Titan. Waiting for another exposure. There we go. And a couple of hot pixels. It's starting to get a little bit chilly. Wonder if we're going to get dew tonight.
It's doable. That moon's wild looking tonight.
So again, we're looking at Saturn, incredibly blown out, but we're looking at the moons. So we have here Enceladus, and we have Tethys, and Rhea, and Titan. So this is a 13-second long exposure. If we drop this way down again, excuse me, 60th of a second. Now we can actually see Saturn. Let's make that a little bit more. 66 milliseconds. Should be able to see some color. There we go. But now we can't see the moons. Not even Titan. Yep. I see no Titan because this is just too short of an exposure. So instead, we see Saturn and its rings. The Cassini division is just that black gap that shows up every once in a while, right there. That's nice. Every once in a while, it shows up really, really nicely, and then it goes away. It does. It's fine. Then it goes away. Fine. Then it goes away. That's what we got to deal with. All right. Is it not showing up? Man, I'm gonna have to get another capture card because mine's kind of stuck. Hang on. There it goes. Yeah, mine's getting stuck. My image is getting stuck. Okay. Yeah, it comes in, it goes away. It comes in, it goes away. It's not too bad. But yeah, I'm definitely gonna need another capture card. Fun, good times. Or something. Gonna have to do something. Oh, yeah. Yeah, I could probably do that. Okay. You ready? Got something?
Do what now?
You got something?
I have Andromeda.
Oh, cool. All right, switch over. Oh, that is nice.
So basically what you're seeing on your screen is M31, which is Andromeda, the galaxy. It's the closest galaxy to our galaxy.
Closest
what,
big
4.5
galaxy.
billion light years away. And,
No, it's like 2 million. 2 million something.
But it's approaching and will become one with our galaxy. So we'll just have one wild mess for several billion years. Anyways, the core that you're seeing there is pretty well defined. It's an easy one to see on a very dark night in a very dark sky location with the naked eye. And it is actually it displaces more space than the moon. So when you look up at Andromeda in a dark sky location, you're going to notice it's fairly large. But you can see some of the banding in there, and the more I take of this, and if I stack them, it comes out to look something like this. Let me see if I can pull it up here. Point. If I can find it first of all. Should be able to. Ah, there it is. All right, so this is one of my pictures that I took as a deep sky object with a color camera. And it's several hours worth of images stacked and processed. I'll be revisiting this, I'm sure, sometime in the near future and redoing it. You'll find as you do this stuff, like this was done back in 2019, I believe. As you do more and more processing, you learn more and can accomplish more. I mean, this in itself is pretty nice because, as you can see in here, the dust lanes within the galaxy are really well defined. So hopefully I can get that done as well in my next image, just cleaning up some of the stuff that you can see here with my use of masks, which was back here not as good as what I know now. But that is what you see when you look, or this is what you're actually taking a picture of, is M31. That stacked will look really nice. And normally those stacks are like 5-minute long images. So, several dozen, if not 100 or more images of that galaxy stacked will net a very nice looking image. I almost hesitate to do the live stack simply because I haven't worked a lot with the live stacking stuff in the software, and I got to figure out how to get out of it once I get into it without shutting down the program. So
Yeah.
We won't do that. But yeah, that's our nearest galactic neighbor.
Well, big one.
big one.
It's not. It's not
I
the
mean,
nearest.
yeah, the small and large Magellanic Clouds are also galaxies, but you can't see those from our vantage point because they're southern objects.
Yep.
They get to see things down in the south that we don't get to see up here in the northern latitudes. I'm sure they probably feel the same way about our objects that we get to see that they don't.
No, they don't.
Oh, okay.
Northern Hemisphere. Well, we have the Big Dipper and the galaxies in the Big Dipper, and that's really about it. I don't remember if they can see Andromeda. From some places they can. Like I'm thinking of Australia.
Yeah.
If they can see Andromeda from Australia, I don't remember.
In Chile, places like that.
From Chile, I think they can, at least from the Atacama. But Australia's
They're on a
furthest.
mountain though.
Yeah. Ugh. Ugh. Right, gulp down ice cold water.
Brain freeze.
No, neck freeze.
Mm-hmm.
Throat freeze.
Anyways, that is my image of the Andromeda.
All right, so I'm gonna try. No idea how well this is gonna work. I'm gonna look at Neptune. Let's see if I can pick out Neptune. Neptune, come on, search for Neptune. So I'm still actually on Saturn. So switch back. I'm actually still on Saturn. Neptune is tiny. Tiny, 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 tiny. And Uranus doesn't pop up till, I think, after midnight. So it's still below the horizon. Neptune is going to be pretty low in the sky, actually. It might not be that easy to pick out. But we're going to give it a try. So it's on Saturn right now. I'm going to do back. And I'm going to do... no idea how it's going to work. Uranus, Neptune. I need to take PhD and say stop. Just let it do this thing. Neptune should be somewhere in the center of the field of view. Okay. I have no idea. Those are stars. And here's what we got to do. I'm going to go here. I need a lot longer exposure. 2 seconds. Let's see what happens with 2.1. There we go. I found Neptune. Well, that was easy. You know how I can tell it's Neptune? It's blue. That's it. It's blue. So let's see. Which direction did I move it? In that direction. Get the other direction. See that blue dot? That is Neptune. So at least I'm close. It's at least in the field of view. That is a huge plus. Okay. So what am I doing? I'm trying to move it down into the center. That's pretty close. All right. That's Neptune. It's blue. And that's the lovely thing about having a color camera is you can tell what color stuff is.
It's blue.
Because when you switch to a black and white, all of a sudden, you don't know.
No. It could be a big star.
Yeah. And it's like, you just don't know. So it's zooming way in. And that is most definitely blue. And there's something right next to it. No. Hot pixels. Let's do 150. I want to see. I thought there was something somewhere over here. But it just looks like hot pixels. The blue, the red, the greens, those are just hot pixels. So let's just get in on Jupiter again. I'm doing a, how much? 3-second exposure, 4.27 second exposures. Let's zoom way in. That's it. That's Neptune.
Wow.
Can you see it?
I can. It is blue.
It's blue. It's what it is.
Tiny and blue.
All right, so here's what we're going to try. I don't know how well this is going to work, but I'm going to, how am I going to do this? How am I going to do this?
That's a good question.
So I want to put a spectroscopy filter on this thing and see what we can pick out. I don't know how well this is going to work, but we'll see. Okay. Yeah. How we're going to do this, I don't know yet. I got to think about this. All right. I got an idea. Because the filter is 1.25 inches, and this is a 2-inch 2-inch adapter. So I'm gonna have to pull it off, put on 1.25 inches, and put on the filter. Okay, so and then we'll probably have to refocus. Don't know yet. I'm hoping nothing moves. Let's get PhD doing something. So here's probably Jupiter or Neptune right there. Let's get this one. Oops. Yeah. Sync it in right there. All right. Let's let that do it. It is getting chillier. I really should have like brought a jacket or something. It's the first time I would have worn a jacket in a while too. It's not even the end of Texas. It's already getting in the 60s. End of summer in Texas, I should say. All right. So, you can see Neptune. All right. So, I guess I should have gotten that. Yeah, I should have gotten my headlight. I need my headlight so I can see what I'm doing. And it's not so interesting watching me rummage through my stuff. I mean, probably not interesting to most people. So I'm looking for a filter. Looking for a filter.
120 plus 90 is 210.
Where could it be? Low filter. This is comet filter. That's what we're looking for. Ha. Yes. Star Analyzer 100. I should probably get the version of it. There we go. So what this is a diffraction grating. And I have no idea how this is going to work with color, but I will figure it out. Okay. Oh yeah, this is going to require. Yeah. All right. The image is about to go away. Now I've got the camera. I actually have to unscrew the adapter. No, it goes white. Unscrew the adapter. I'm looking at the sensor. Ready. Screwing on centering adapter. Putting this back in and ever so hoping for the best. How horrible is this going to look? Oh, completely. Totally. I see nothing.
And this is just a filter?
Yeah, but I changed my focal length.
Oh.
I changed the focus completely. It doesn't matter.
Not to mention you have to refocus because you put a filter in it.
And what I actually have to do, it's even worse than that, because now I have to go find something big and bright, like Jupiter.
Yeah.
So I have to go back to Jupiter because it's super bright,
Or Vega.
just so I can see something to focus on. Okay. There. Oh, that's cool. All right. Where's my PhD? Stop. Okay, just do that. All right, cool. So this is actually kind of neat. So what I'm looking at is the diffraction grating. This is I think it was like a thin piece of glass or plastic that's very, very finely etched. There could be several thousand lines on it per inch, if not more, tens of thousands of lines. And what it does is it basically just takes the image and stretches it out into a spectrum. And this is what I pretty much want to see, except that I need to center this thing out. So, come on, down. Nope, wrong direction. Yep, down. Hello. Then over just a tiny bit. I should probably, yeah, I can knock this way down instead of 2 seconds. All right. All right. 2 seconds, less than that. All right. It's big. It's bright. I don't want it like this. I need to focus it. Where is my focuser? Nope. There's my focuser. All right.
Also looking like it's good, well collimated.
Oh, it is. I put Bob's knobs on there.
Okay.
Yeah, I replaced the stock ones with Bob's knobs.
Yeah.
And I figured out a really, really good way of focusing, or sorry, of collimating it. Which way? Out, in? Nope, wrong direction. Of course.
I've never had too many problems with my collimation when I had my Smith.
This one, it wasn't grossly out, but it was enough that it was highly annoying. So what I actually did is I took it and I had it on one side of the house. What is that, dog?
Yeah.
Okay. I had it on one side of the house, and I was shooting as far as I could across the other side of the house, indoors because it was winter. And I took a flashlight. I covered it over with first, what was it? Like a translucent plastic, and then I put a aluminum foil over it, and I found the smallest, tiniest little pin I could find, and I made several holes in it. And what that let me do, oh yeah, there we go.
So basically, you made your own
artificial star. That's it exactly. And the reason why I put the plastic over it, because I wanted round stars.
Yeah.
I did not want an image of the sensor. And so by putting the plastic over there, it diffuses the image of the sensor, because otherwise I would literally have square stars. And I did not want that. Oh, there we go. There we go. That would be...
Let's check that moon out.
Yep, that's the shadow.
It's pretty.
So we're still seeing the shadow of Io. David, yes, we're down in Grandview. So this is out on family land, out in the middle of nowhere. Thompson has Thompson Foundation site is one of our dark sky sites for everyone else. However, the internet access out there is not great. There is Wi-Fi, but it is metered Wi-Fi, and I think we would do about half an hour of streaming and eat up their bandwidth for the month.
Probably.
So they would not be terribly happy about that. And at Star Ranch, the reception is not great. That's pretty much in the middle of nowhere. So down here in Grandview, we've got pretty good internet, running a nice long Ethernet cable out to here and running it off of that. Bugs on my screen. And we're able to run a multicam setup, multi-computer setup, multi-telescope setup. It's quite nice, actually. I'm pretty happy. And again, we have the shadow of Io on Jupiter. So if I zoom out just a tad, we have the spectrum of Jupiter. But because Jupiter's such a big object, I'm not really able to get a usable spectrum. Instead, we're going to try this. Saturn's not a good object either. Uranus is a really good object, but we're going to try with Neptune. Please, please, please be in the middle somewhere. Okay, I'm starting to get chilly. I don't know about you, and I completely forgot.
I wore pants.
Oh.
I didn't want to deal with the bugs, so that's why I wore the pants. I didn't expect it to get this chilly, but
I'm glad I wore socks, not sandals. At least there's that.
Yeah.
All right, let's go back to the here. All right, where could this be? Oh, I need a much longer oh, wait, hold on. Thought I saw something, but we're going to go to a much longer exposure. I think it's there pretty much in the middle. I don't see. Maybe. Is it that in the middle? Yeah. It's off to the side. 8-second exposure. Yep. That's it. That would be Neptune. So I have to move it in the other direction. Let's get it moved over. Hey, we got a spectrum off of it too. Okay, that's pretty cool. There's that little line there. I just got to get it in the center, or close enough to the center. Come on. A little bit more would be fine. But that's not too bad. Okay, so that little streak, should be able to just barely see it, and we'll take a longer exposure as well. That little streak will let us, yeah, a little bit more to the center. Oh, shit, well, that was, I already had it there in the center. All right, fine, whatever. We'll let that thing go. Let's check PhD. I'm going to do stop and loop it again. And so this should be it right there. I'm going to grab a different star, a real star, and I'm going to start guiding on that star. Come back here. We're good on this. Let's give one more exposure, and then we'll just get a little bit more because I want a little bit more data in that. Okay, that streak right there, that's what we're looking for. That's actually the spectrum right here, that line. So I want something longer. Let's do 17 seconds. See what happens with 17 seconds.
Yeah, one of these full moon nights, or one of these nights when they're not doing a whole lot, we can get together and we can do a Pen Pro on your deal and pec train it. I mean, it won't take more than an hour.
Really? That's it?
It don't take
long. Wow.
It depends on the size of your gears and how many steps there are in it. That determines how many cycles you have to run, or how many minutes you have to run.
This is also the enhanced encoder version.
Oh, well, then you should be, yeah. I mean, once you get it, what do you call it, polar aligned really good, then you shouldn't have any problem at all.
It's polar aligned right now. Where did it go? 34 seconds. Okay, that's why. So we're going to do a 34-second exposure, and I'm going to do a quick capture. Let's make sure this one works.
Ooh, blue.
So a little bit more time, 10 more seconds. So we'll pull in that image. We'll see what that spectrum looks like, that line. We'll run another one and then save that one. We'll do a capture of it, and then we'll bring that into our oh, that is lovely. That's what I want to see right there. That's it. This is good. So we're seeing Neptune, and that's Neptune, and we have burnt out pixels, and here we go. This is what I want to see. You see these dips coming through here? Right there. Not those horizontal lines. That's just an artifact of me scrolling. We'll see a new one pop in just a second. Right there. Those are the dips that we want to see. So this is good. This should be the methane line right through here, where that dip is. But we're going to drop this into our spec, and we're going to see what it says. And I'm going to, I guess I could try to focus it a little bit more. Let's do that. Let's focus it. I can't believe I forgot the damn Batman mask. It's yeah. I'm gonna
Of all things you could forgotten, that's probably the least impactful.
really.
Yeah, I could think of a lot more that would be
Well,
a
yeah.
lot more painful. At least you're up and running.
There's that. I'm gonna cut this thing down. 17 seconds. This is so.
It went over, so I need to
to push my gain way up. Let's do 8 seconds. I gotta restart it. There we go. So this is stupid amount of gain, but I just want to be able to see. I should probably cut this way down too. Yeah. Yeah, if I had the Batinov mask, it'd be just no problem. Nope. Too much out. Yep. So I'm just trying to get a little bit tighter focus. You know what? That should be fine. That should be fine. All right, let's do this. I'm going to do the auto gain, and then I'm going to punch this up to, oh, not that much, 34 seconds, and I'm going to do, got to call this thing Neptune. Neptune light frames. We're going to do, start the capture, and we're going to do single frame. Let's do like 3 frames, and then 22, not 22, 42, 2. How about 3 frames? And then start. Okay. So we'll see what it captures, how much it captures. 34. Oh, shoot, gain. We gotta drop gain way down. Gain is
ISO. In general.
Yes. And ISO with computers now, it's ISO and gain are pretty much the same thing. So what it actually does is, oh, I'm picking up 2 of the moons.
Oh, nice.
Oh, cool. So one is, let's see. Yeah, I'm picking up 2 of the moons. This one is what? No, that's a star. No, those are 2 stars. Those 2 right next to it, those were stars. Those were not moons. Oh, well. Okay.
I was always taught that you thought of gain as a bucket. And when you add a higher gain, you are basically pre-filling that bucket so that you have less room in the bucket for other photons. In other words, you're not going to get, if there's nothing there and it's black, you'll have something there.
I thought gain was just multiplication of whatever you get in there. So it's not pre-filling it necessarily. It's, if you have 1 photon, it counts it as 10.
Now I always heard the bucket thing where it's like,
all right.
What was it?
Oh, SCR. I do not want SCR. What I want is TIFF or FITS. I want to try FITS. Start the capture again.
Oh, there we go.
Okay. So that's the rainbow I want. That's the pattern I want coming off of Neptune. So that's the image I want. Now we got to bring up the application called RSpec. Real-time spectroscopies. This is a neat little application. And actually down in the Waco Club, the Central Texas Astronomical Society has a very lovely 24-inch telescope. And it's a research-grade telescope, and they have a 2-inch filter on their scope. So they can do spectroscopy from the scope down there. And I am also now a member of that club. And I need to finish up my training on that telescope. And what I would love to do is be able to do a remote star party from the comfort of my own house, especially in the winter, where I can remotely connect to the telescope and access it, and do stuff from the house and just transfer images over. But before I do that, I really want to do a star party from down there. So getting all the equipment together and testing everything, making sure it all works. That's the plan, so that I can head down there and do a star party from there first before I do a remote one. Let's do RSpec. Why did I load it twice? Okay, open. Okay, I'll just pick one of them. All right, let's see if I remember how to do this right. Okay, this is not good. Instead, I can do, let's see, rotate. We do rotate, and what we want is we rotate the image. Wrong direction. No, well, we only have one direction to go. I swear this is so slow sometimes. Don't do the live update. Right about there. Nope, too far. Maybe. Nope, not far enough. Too far. That's close. That's pretty close. Almost there. Almost there. And we want is this. There we go. That's what we want to see. Okay? So, get this right in. Hopefully y'all can see what I'm doing. Okay? Man, I'm getting some YouTube video errors. Not enough video to maintain smooth streaming. Well, we're gonna have to figure out a way to fix that. But in the meantime, I'm not gonna worry about it. This is not too bad. I can actually come in here and do subtract background. No, I don't want to subtract background. It's too jagged. That's what I kind of want to see. All right. I completely forgot how to use this thing. It has been a while since I had to use this thing. So let's see if I can do this. I can't calibrate because I do not have click on pixel number 1 in your profile. I guess it's here. No. I can't remember what these wavelengths are. I want to say it's somewhere. You know what? I don't think I can calibrate it. Close it. What I can do is view tools. Oh, let's see if I can remember how to find this. I haven't used this in such a long time. I have to go through and figure out how to do this. There we go. That's what I'm looking for. Methane. And no, I wanted to show methane. I didn't want to close it. So here's what we're doing. We're showing methane lines. And then I have a calibration reference. Edit points. There's a number which I was looking for and I don't see it. It's not here. So the calibration is pixels wavelength. No, non-linear. No. You know what? I don't remember. I don't remember where it is. I just don't remember. So what I should be able to do is I can move these lines over and they will actually point here, here, for at least 4 of those for these lines. I don't remember what this is. No. This is what we're looking at here. And This is a methane line, but it's not in the right place because it's just not in the right place. Where is it? 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 No, I don't need the Balmer series. Yeah, I just don't remember where I put it or where this is. And there's a calibration for it, and I usually have to calibrate off of a star, but I remember what the number is. I just don't remember where to put in the number. There's a, yeah, I just don't remember. But these dips here, 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 and I think there should be one over here if I zoom in on it. Those are 1, 2, 3, and 4. So if I squeeze those in on those places, and that's the calibration bit. I thought, yeah. Yeah, I thought it was. I have not done this in such a long time. I don't need a reference series. No. I know exactly how much it is. 1.54. That's my number. It's 1.54 because I've done this before and I don't remember how to move this over. So it's like it starts it off at 1.54. If I do calibrate, click on pixel number 1 in your profile. What if I do that? And here, I just don't remember. Nope. Use 1 point alignment. Aha. That's what it is. 1.54. I think. Let's see. Pixel and wavelength at the top. Pixel number. Oh, pixel number 1, of course. That's this. Right there. Okay. Wavelength 0. That's it. Apply. But that's not right. That's not right. So, yeah, this isn't right. This isn't right. Oh, because I'm not doing it on the right side. Oh. You know what we have to do? I know what we have to do.
What?
Rotate. I'm rotating in the wrong direction. 315 degrees. What's 180 of 350? 313.5.
You want to know what now? 180 plus what?
No, I got it. That's what's wrong with it. Now we got it. That's gonna be pretty close. Yep, wait, bit up. Okay. Yeah, that'll do. Now I've got it figured out. Okay. Pixel 1. We're gonna click right there. Okay. Pixel wavelength 0. Apply. All right. Now we're going in the right direction. Now we'll be fine. And I want to say this is 2.54 or 1.54 is what I had previously. Apply. Maybe. Now I can come here and I can say that's not the right number. All right, let's suck this in then. How many angstroms? Oh, because it's a different telescope. Of course it's a different telescope. Okay. That was it, right there. So on this one, it's 5.4. And that's where we got some numbers. All right. Well, now it's kind of doing it. Okay. All right. Well. Okay, now we got something. So we're going to kill that. So here are our methane lines. I'm going to bring it over this way so we can I guess see them a little bit better. Right now they're kind of hard to see. Okay. Again, I haven't used the software in 6 months. So, where is my zoom? I have a zoom feature on here. I would love to have a zoom feature on here. I can print it. But here, I did it again, didn't I? Yeah. If I do this, turn methane back on. Here we go. So if I do appearance, nope. Thought I could zoom in on this. Oh yeah, I can zoom in. Hold on. See if I can. Oh, that should be good enough. So, yeah, that's pretty much it. I guess I can just crop it down or something. Um, Measure lines, auto scale Y. Use second. Nope. Nope, that's fine. Average 200. I don't know. See what this does. No idea. So what I'm trying to do, synthesize? Ah, there we go. Now we got some colors. Oh, okay, that is cool. Logarithmic Y? No. That should be actually okay. Auto scale to Y. Now we need as big as possible. Wonder how I can auto scale it. Can I do this? This? No, it doesn't let me do that either. All right, so what I'm seeing, that's how it should be. So the lines here, these are the methane lines. So the methane lines are where there's methane in the atmosphere. It is absorbing light from the sun, and the sunlight is being reflected back from the atmosphere of Neptune. So, yeah, that's it. That's it. So this is the light from Neptune all together, and then this is the light from Neptune stretched out, and then here it falls off into the infrared. So this telescope is not great at picking out infrared, and over here, there's ultraviolet, I guess. You pick up a little bit of it right there, but there's our reference. So that's where we saw these drop-offs, especially strong in the green. And we saw a little bit in the red, apparently the red to the yellow, but they're just really hard to see. But the drop-offs that we were seeing here, do it again. We can definitely see these drop-offs here in the green going there. Do we see anything in the blue? Let's see if there's anything in the blue. What? No, it's not what I want. Oh, no wonder I have two versions of it running. Yeah, let's not do two versions of it. So again, that's that. And then on here, so we see a ramp up in the blue, but there's not any methane cutoffs there, except once we get to that blue-green transition, and we have some more through here. So if I turn this off, we can see those drops, and they do correlate. So that's an indication of methane in the atmosphere of Neptune. What I could do, yeah, I have to take the image and I have to crop it way down in order to get more of it. So Neptune, and then we can also look at, is there mercury? Not really any mercury. Is there water? Yeah, looks like there's some water. We have a dip out here in the red right there. That could be indicative of water. And remember, this isn't a very big telescope. This isn't a fantastic diffraction grating. If I really wanted to, I'd need a diffraction grating that would really, like a 2-incher, that would really stretch out the spectrum. If I could do that, we could really pull out some more data. So that's pretty cool. What else can we see in here? Argon? Maybe, but not really. There's probably not going to be any calcium. Specifically, these are different types. Is there a laser? No, you can't tell. Krypton, iron, magnesium. There's not going to be anything in there. Helium. Um, I don't really see any helium lines in there. Helium's probably all the way down. Methane is primarily what we're looking at. So that's what we want to see. That's what we got. So we actually were able to see methane in Neptune's atmosphere. We did real science. This is actual science, not just looking at pretty pictures like George does over there. You got anything over there right now?
I have a stacked image of the Western Veil.
Okay. Oh, very lovely. So you got reds and greens in there?
I got some blues.
Oh.
Teals,
Teal.
which is oxygen. Oh, there you go.
So what do you think of the sky right now? It's not bad? Not great?
It's not too bad. I mean, it's getting better as the night goes on, and I think it's supposed to, like, by Monday afternoon, we're supposed to be out of most of the purple, but
we're next week is also rain in
yeah.
forecast for us, so maybe that'll clean it out.
I mean, we've got all the Sahara Desert stuff going over us, and the smoke, and it's just covering everything right now.
Yeah.
So I don't think anybody's getting away with clear skies tonight.
It is what it is.
Yeah, deal with it. Go on.
Yep. All right, I'm going to see if I can find is Uranus coming up or not yet.
Let's see.
No, it's just barely above the horizon. Yeah, there's nothing to see. So maybe while you're doing that, I'm going to jump on and I'm going to go look at stars. So I'm going to find something that's good. Oops. Menu. All right.
So yeah, what you're looking at here on the photo that was on there was what's known as the Western Veil. There's the Witch's Broom, or the Eastern Veil, and then you've got the Western Veil over here. I think that's right, isn't it?
Yes. I think so.
But anyways, it's a whole complex of nebula that, if you have a wide enough view of it with a telescope, you can pretty much grab this whole complex, and it's all reds, blues, and almost a whole, nice little thing of HA and oxygen 3 and even some sulfur in there. Not a lot of sulfur, but just enough. But yeah, it's quite beautiful. They've actually got several different loops, which are they call these loops. Basically, it's a supernova that went out, and you're seeing the expanding wave fronts of gas go out from where the star was, which would be somewhere in the middle there. And then you'd have like the Orion complex, which is a huge loop. And if you had to do it, you'd have to do it with multiple frames taken over, weeks, if not months, unless you had a really, really, really wide field view of it. But yeah, it's huge. I mean, it's just a giant, expansive circle of gas and dust that's being pushed out from the center. So when you look up and see the Orion Nebula, which is part of the Orion constellation in the Sword, just realize that that's just the tip of the iceberg as far as what you can see on that particular object. Oh, let's see here. What do we got?
All right. I've got Deneb.
And what you're seeing on the screen here in front of me is a live stack. Currently, it's at 5 122nd images, and yeah, my mouse doing particularly good tonight. I'm looking at these. I'm seeing all the stars. They're not trailing at all at 2 minutes. I've gone as far as 5 minutes. Anything past 5 minutes, and I usually rely on guiding just like everybody else. But yeah, it's nice to go out there and just go to town, and you'll have to throw out a couple because the wind blows or something like that, or you walk past it heavily and it kind of vibrates and makes the ground shake a little bit. But for the most part, what it's doing is it's basically taking an image and overlaying the stars in that image over the last image and adding more and more definition and color to the image as you go. And this is almost straight up. If you were to look over at my scope behind me, it's pretty much standing on its head. It's looking straight up, which I'll have to do. Well, I'm not too bad off yet. I've still got about another 30, 45 minutes before I have to do a meridian flip. Speaking of, that's where your telescope gets to the point where it's past the meridian in the sky. That means it's gone past straight overhead. And if you let it go too far, if you have a regular mount like we do, which are equatorial mounts, your telescope or your camera will bang into your tripod or pier, which causes damage, and you don't want that. So you end up doing what they call as a meridian flip. It will flip it to the exact opposite side of the telescope. It'll, instead of being on the west side, it'll be on the east side. Or no, instead of being on the west side, it'll be on the east side, and it'll start tracking more towards the west, which means the bottom of the telescope goes farther and farther away from the pier or the tripod. Just a little info. The software I use for automated image acquisition knows that when it gets to a certain point in the acquisition, that it needs to do a meridian flip on its own. So it will schedule it, and when it gets to that point, it just automatically flips it over the other side and starts taking pictures. And because I've got what they call a rotator focuser, it can actually take a picture of the sky, determine where the rotation is as far as where the camera angle is, and rotate the camera around so that it's at the same angle as it was when it was on the western side of the meridian or the pier, which makes it nice because you don't have to worry about in your processing software, letting it do the flipping and gyrating and doing all the stuff that it needs to do to make the image look nice when you do a stack. But yeah, it's looking nice. We've got some teals, which is the oxygen 3, and you've got the reds and the pinks and whites, which is the hydrogen alpha. And like I was discussing earlier, this is just a wave front. This is like a giant wall of gas and dust that's being pushed away from what was a supernova, which is a star exploding. And by the way, everybody is made from star stuff. So if you ever wonder where you're coming from, look at one of these objects and know that a lot of the stuff that's in it is in you.
That is very lovely.
Yeah, I find it, if you go and look at like Betelgeuse and a lot of the, what's Arcturus? We've got several stars that are huge. And I mean, by comparison to our sun is like middle of the road, standard yellow
dwarf.
Dwarf, yeah. It's very stable. It's and if you think about it, all the tons and tons of hydrogen that it's burning or converting just boggles the mind how it can burn for so long. But yeah, they've got suns out there that just make it look like a little speck, like our Earth compared to the sun, if not smaller.
There was a new one that was just discovered as well, and that's got the title now for biggest star. It was like, I want to say it was like Stevenson something is what it was called. Or what it
in December. December, that's the date, a month to remember, because that's when they're going to, quote, launch the John Webb Space Telescope, which should be able to see
James Webb
edges of our universe.
Right,
that'll be amazing. 2 million miles away from Earth.
Yep. Okay. Trying to rotate that. Does that look good? That should be fine.
I think we're up to 8 stacked and 1 ignored. That's not too bad.
It's pretty good. I mean, it looks like a much longer exposure. Or
I could probably go to a 180, which is 3 minutes. This is only 2.
All right, auto scale that. Okay, so while that thing's going, I'm gonna switch back over here. Oh, I'm missing something on here. Where's my scene? And I'm missing. There we go. So this is a image of Deneb, which is a star in Cygnus, constellation of the Swan. And I've got the diffraction grating on it, and it's taking an image every second. One every second. You can see it's significantly brighter than Neptune. So Neptune took, was it 16 seconds or something? It took a while. We had some decent long exposures in order to get a spectrum. From here, we're getting a pretty good spectrum right away. So what did I do? Save the file. Oops. Then I'm going back to RSpec, and now I'm taking a look. So now I have a very well-defined, I can actually calibrate this again, calibrate it and say, this right there, that is pixel 0, wavelength of 0, and apply. All right, so now this is where it starts off. So I can now go through and I can look at the spectrum. So we have indigo right there, and then we have in the blues, the greens, fall off in the reds, and then fall off further here in the infrared. So I'm actually able to pick up some of the infrared on the chip here, which is nice. We can't see it, but we're able to see some of it there. What does that mean? Well, it means we're going to be able to do this. If I click on here, doesn't look like it's a type O star. Doesn't look like it's type B. Should be a type A. But where's my calibration? May have to stretch this out. So, oops, wrong direction. No, I think I was right. I think it was right first at the beginning. Oops, up. It was 5.5. Yeah, right about there. So I'm able to see these drops, especially right here all together, and then another drop right there. So it turns out that Deneb is actually a type A. If we look at others, type F's, it's very similar. Type G, which is our star, it's missing a dip there. Not type K, not type M. See type K again. Nope, it's missing some of those dips. But we can go through, we can see what does it have. Does it have calcium? Hey! It's got a line right there for calcium. Not necessarily, usually, well, it would really have to have all of those. Runoff, or I forget what those are. Water lines, not really. Helium, maybe. Probably not, though. Hydrogen polymer lines. Yep. Iron and magnesium. Just go through all of them and see what's in there. Krypton's got a lot, but I don't know. Is it lasing? I don't think so. Mercury doesn't have any methane. Should not have methane lines. This is not a nebula. Neon. I don't remember what Ralco Basic is. I don't remember any of those. I just remember this thing is a type A star. I think it's type A5 specifically. So, again, neat science. We can actually see the dips here in the purple, violet, I should say, a peak in the green, and then that drop right about there, whatever that is in the yellow. Excuse me. It is now 11:05. Wait,
Counting down the minutes.
Well, it's going to take me a while to pack everything up.
Yeah, I can attest to that. I know all the stuff he's got out here.
Yeah, so it took almost 2 hours to get everything set up. So, fortunately, I can dump most of it back in the car and drag it out tomorrow morning, as opposed to dragging it out tonight. So this is spectroscopy. This is our spec. It is quite a bit different than imaging, but it is really neat because you can see stuff which you really can't see just by imaging. I mean, let's go back to here. Wherever it was. Did it move off? It may have moved off. Oh, it did move off. Well, that's nice. So, what else can we look at with this thing? M45. I'm going to try to look at M45. And you...
Is that up yet?
The ring? M51.
I was going to say M45 is...
Yeah, Pleiades not up yet.
Pleiades.
Deep Sky, Messier, M51. Ooh. Yeah, it's chilly. I will say it's chilly. I'm kind of surprised. Yeah, I don't remember what the we can hear the crickets. I don't remember what the formula is for figuring out what the temperature is based on crickets.
There's a formula for cricket noise?
There's a formula for crickets.
Oh my gosh.
So let's see. Crickets temperature. Okay. It's surprisingly simple. To convert cricket chirps to degrees Fahrenheit, count the number of chirps in 14 seconds and add 40. Okay. They only chirp between 55 degrees and 100 degrees. Okay. So, okay. That's interesting. All right, let's get a longer exposure instead of just 1 second. We need something much more. I'll get a 30-second exposure. In the meantime, where's my stopwatch? Okay, I will do a timer for how much? 14 seconds?
Yeah. How many times after 14 seconds?
Delete. Delete. I need to do timer 14 seconds. So, okay. $27 plus 40, 67 degrees. Science.
Just a bit chilly.
Why is it all... Oh. Because it's pointed at George.
The light nebula.
Yeah, are we pointed... I don't even know if I'm pointing at the right location.
I don't know. What are you trying to get to?
Ring.
The Ring Nebula?
Yeah.
Well, let me see.
It's not M51?
I don't think it's M51. You're talking Ring.
The cold has gotten to my brain. I'm not...
That's a possibility, too. Ring Nebula should be just the other side of the meridian on the west side.
Yes, but what's Ring 57?
And it is M57, yeah.
55, 6, 7. Try it again. This was shining directly at George and his light. That's why.
It's a race.
So, according to the crickets, it is 67 degrees. Okay.
It's a little bit chilly.
Yep.
But I can deal with it down to about 55. Once it gets back below 55, I start shivering. Which kind of sucks.
All right, what are we looking at? It is up. All right, we're going to wait for another exposure. Oh, let's jump off to Push here, dummy. Oops, that's not it. Push here, dummy. Don't see where the ring is. Let's get a longer exposure. I'm going to get a 3-second exposure out here. It might be popping up. I can get it centered out. Okay, it's hard to see. Where is the ring? All right, so I'm looking at 1, 2. What am I looking for?
Yeah, that's about right.
Yeah, Mom. I don't see anything.
See if I can see it.
Well, you know what would really help? If I didn't have a spectroscopic filter on there. That would
Hey, there
really
it is.
help.
I can see it.
Yeah, I can't.
Wow, it comes through really bright on the.
What, ring? Oh,
Yeah.
switch it over to you.
I mean, it's a
Oh,
bright
yeah.
one.
Oh, yeah. I mean, I should be able to see it, but I
You
can't.
should be able to get really
All right.
close to it.
I'm going to take off this. Wait.
Go for it.
Yeah, I'm going to take. Wait, first. Oh, first of all, I got to stretch. I've got to move.
Yeah.
Sitting in that
You
chair.
kind of stiffen up as the weather or the temperature goes down.
Yeah. And I'm also going to check Sky Safari because while I'm up, Sky Safari is a neat little application on the phone that there it is, that I can use to figure out where I am.
And what'll be interesting is once he gets his going and takes a picture at his focal length, we can compare, because this one, what you're seeing is a focal length of about 808 millimeters, which is, it's fairly standard. My 127 without any kind of focal reducer was at 950, I think, prior to getting this telescope. But also in this picture, you can see a satellite trail, which neither here nor there. I mean, we'll see how it goes, but you're going to start seeing some more of SpaceX and some other stuff happening with satellites is whizzing by all these nice little pretty sky objects.
I just don't see. I just do not see anything. Yeah, I don't see anything. So okay, specifically, let me go back. I do not see Uranus above the horizon any decent amount, and it's also getting late and cold, and probably I don't really want to spend a huge amount of time
waiting for it to come up high enough that you can actually do anything with it.
and just basically freezing.
So on your telescope, do you have the filter drawer, or you actually have to take it apart and put a new one in?
Yes.
Oh, okay.
I do have a I have a 2-inch filter wheel.
Yeah.
But it's loaded up with luminescence for a sky glow and then a Hubble palette.
Gotcha.
So, and yeah, it's getting cold.
Just a bit.
It's getting to the point where it's not comfortable. And I really should have worn pants.
Your pants work good.
And a jacket.
I was thinking about bringing a jacket, but I thought, nah, it's only going to be in the 70s.
It's Texas in the summer. Why would you wear a jacket?
Exactly. Yeah, the moon was nice tonight. It was as red as could be. It was when the closer it got to the horizon, the more ruddy it got, and the nicer it looked. Yeah, it's fun to look at this. If you look on the screen, you can basically see some nebulosity, the red color. I don't know if you can see that really well on YouTube or not, but yeah, it's it's got a little nebulosity around the Ring Nebula. The Ring Nebula is a planetary, which is a star exploding but not quite going supernova. It's just shedding the outer layers. This is what's going to happen to our star when it finally gives up the ghost and decides to become a brown dwarf and just kind of be the heavy object out there with no light. But
Eventually, one day.
yeah, in about 4.5 billion years, if the timetables work out that way.
Oh, okay.
We won't be here anytime near that because of the fact that the sun, as it gets older, will start getting bigger. And by the way, if you're ever in a scouting situation and you have little Cub Scouts around, don't start talking about black holes and stars exploding. Some of them don't quite understand. I was an old I'm a scouter, so I did a lot of that and kind of tried to explain to a bunch of kids about that, and
And all you did is
all I
terrify
did
them?
was confuse and make them scared. So yeah, word of advice: if you're ever with a bunch of kids, be they girl or Boy Scout or just kids in general, kind of keep it on the down low as far as stars exploding and black holes.
Children, one day you too will die. Jeez.
Or Dylan O'Donnell in his interesting saying.
Okay, so I'm gonna try to get Deneb again, because I need something to focus on.
Instead of the cold.
No, I mean I need to start a focus on because I got rid of my
I see what you're saying.
spectroscopy filter,
Yeah.
and I went to my 2-inch, and now I need a bright star to navigate by, so to speak.
Yeah, I could probably drop this down to a little bit less, like maybe 90 seconds. I'm going to try that. Where's it at? There it is. Let's go to
Yeah, I need something.
something other than 120. Let's try 60. And yes, I want to get rid of it.
Where's mine?
This should speed it up considerably. Yeah, I've got my my gain set at about 100 and my offset set at about 50. So it's pumped, as they say.
Okay, so I've got that. Now what? Well, where did my focus tool go? Don't be gone. It's gone. I had my.
Yeah, when I did my polar alignment earlier, I should have used my pole master. That would have been a lot easier and a lot quicker. I could have done that and just done a quick 50 point T-point run, and I would have been ready. Live and learn. Oh, that's much better. You can see more detail in the middle.
Yeah.
And you can actually see some, I think there's, right there, the star, the actual
The white
original
dwarf.
star. It's not as well defined as it should be, but it's not too bad, considering the focal length I'm running at and the fact I'm cropping as heavily as I am.
Okay.
Yeah, they have something called the Helix Nebula, which is also a planetary, and it's glorious, but it's they also call it the Eye of God, and it is wonderful. It's huge compared to the Ring Nebula. And if you actually can take a picture of it, it'll fill your image sensor.
If your focal length is long
Sure.
enough.
If
your focal length is long enough.
Even at 800. So
That
let's
big?
see here. Show you what I'm talking about.
Okay. Here we go.
Boop, boop. Telescopius, if you get into doing this kind of stuff, is a wonderful, wonderful tool. I actually donate to them regularly. All right, let's get there. And what that gives you the ability to do, this is a picture of one of the people that use Telescopius. They upload their pictures for us to get an eyeful. But yeah, you can see the central star in a lot of these. And it allows me to put my equipment in there focal length, cameras, aperture, the whole 9 yards. And this is what it would look like if I had it in my viewpoint right now with the reducer and everything. And if I went up here and did ring, so keep an eye on that right there. This is the Helix Nebula, which is a rather large planetary, and it's in the southern area of our sky and quite low. It never gets above, I believe, maybe 34 degrees, 36. So let's take a look and see what it compares to the Ring Nebula, size-wise. And there you go.
Well, that'll be a difference.
Yeah, it's a big difference. It's closer, and it's just a much better nebula to actually look at as far as a planetary.
It's just better if you go further south.
Yeah, you just have to go further south. Like, it's up right now, but with the lights that we've got and the dirt in the sky and the smoke and stuff like that, you're not going to see a whole lot of good pictures of it.
All right, well, I'm going to try to focus on this guy.
Go for it.
So we can get.
I could probably even drop that down more.
Oh, wrong direction.
Pop that down to 30 seconds and see what I get. That'll make it go even faster. Ooh, we'll get some nice stacking going here.
All right, I'm pretty good for focus, I guess.
There you go. You can see the central area and the wavefront on the outside, the red, hydrogen alpha, oxygen in the center. Yeah, I'm quite pleased with the ASI tool. It seems to do a decent job. Let's see, where are we at right now? As far as the Helix.
I'm just not able to get a decent image out of this thing right now. My focus just doesn't seem good.
Let's shut that down there. Go here. Go. Let's go.
Yeah.
Helix Nebula. All right. Wow, that's still low. Let's see if we can hit it though.
Okay. I think that's as good as my focus is going to get. What's the I'm going to try to get sky messy. I'm going to try to get M57 again.
Going over your way. Wow, that is low. Let's see what I can get out of it though. I'm going to try. I'll go back up to 120, see if I can get anything out of it. Right. Yes, clean it up.
We'll see if it's anywhere in my field of view, but I doubt it. I'm trying to get.
Go for the ring?
I'm trying to go for the ring.
You should be able to get something halfway decent as far as
but my pointing isn't decent. That's my problem. Wrong button. I'm trying to figure out where this is on here. They've got a big field of stars. If I could center it out, I could pick it out. But I'm not sure where it is. Big old field of stars. Here we go.
Figure it?
I'm trying to. This is it right there. Yeah. I'm not. Yeah, I'm not pointing in the right location.
I know several guys that have been able to use plate solving with stellarium and
Yeah. I was going to try it, and then it's like, I don't have time to do this right now.
Coming up, 122nd exposure on the helix. Let's see what we get. That would be kind of fun if we did get something on it.
I'm about to find out.
We'll see.
3.
Ooh, ah.
Oh. Hey, you got it.
That surprises me. That surprises me. And that's got the star in the center of the Helix Nebula, too.
Just barely there, but it's visible.
You look at it right there.
Very
That's the
nice.
original star that caused all this nice little gas to be
Well,
ejected.
It's the remnants of the star.
The remnant of it. Yeah, it's probably a white dwarf by now. But,
Yep. That's all that's left.
But yeah, this thing is, if you get this thing stacked in a, you actually take some astrophotography of it with 5-minute exposures and the like, and stack them all, it looks gorgeous. And if you use a color camera, you get the blues and the reds and the nice whitish color gas, and it just pops.
Oh.
I'm interested to do the RGB or LRGB filters. I haven't ever tried those yet, so I've got to go to a dark sky site to do those.
Yeah, it just takes time. That's all that it is. So I'm gonna try one more thing. I'm just I'm just gonna do this. I should have done this earlier in the night, but we're gonna do it now. I'm gonna just do a 3-star alignment, even though it's 11:26.
You shouldn't have any problem.
Yeah, it's just once an exposure. Okay.
And for those that want eye candy, you can go to a site called astrobin.com. Free to sign up. They'll let you keep like 10 of your pictures out there if you really want to put pictures out there. I've got lots of pictures that I do, but I have a membership with them. But yeah, Astrobin, you can look up any kind of object that you want to look up if you know the name of it, or even if you just want to look up a specific type of object, like a planetary nebula or something like that. A lot of them have tags that will allow you to look that up, and it'll just throw picture after picture up after you. And it's just, they're gorgeous. I mean, a lot of them out there are done by guys that just, this is their passion, like a lot of us, and they take a lot of time to do it, and what they produce is amazing. Guys like me, I like to troubleshoot and figure out ways of making it so that I don't have to troubleshoot later on, and then help others that maybe don't know how to do certain things.
Yeah, troubleshooting is fun if you actually figure out the process and actually are able to do it. And I will say this: I actually had issues with doing it on my end, getting it all set up the way it should be, to the point where I pretty much wasted 2 years. Many so many nights of trying to get my equipment working right, testing this, testing that, making sure, thinking I was on the right track. Turns out I wasn't. So much frustration, and it was a single setting in PhD, and the way I had it configured, and that was it. Once I figured that out, it was like, oh, okay. But I literally wasted months.
Ooh,
nice. It was, well, it was more than months. It was like 2 years of frustration, 2 years of trying to do it right, it just never worked. So I got frustrated. I left it alone for months, and then came back to it. Oh, I think I got it. I think I got it. And finally, after just playing with it over and over again, I managed to figure out the one setting that I really and truly needed. And this is I need less time. I'm trying to do a come on, move it. I right now I'm trying to realign my telescope, and so the way I'm doing it is I'm why
Yeah, he's training it by telling it, or slewing to a star and then centering the star and telling the computer hand controller that he's got that that's the star he's at. And if he does that for 2 or 3 or 4 or more stars, then the hand controller can adapt, and the next time he goes to an object that he didn't point to, it'll know where it's at in the sky based on triangulation and
yeah, and right
calculation.
now it's not working out the way I want it to, and I don't know why yet. It's like I mean, I can see why. It's just going totally the wrong direction. And I'm yeah, so my end is boring right now. At least you can see something with George's side, but
Yeah, as you can see, I'm stacking more and more information, and it's causing the colors and the definition of the object to become more distinct. The nice green and teal in the center, and the reddish color on the outer side of the helix. And you'll notice in the lower right-hand corner of my image, there's a black dot, and that is because I have, dust or some other kind of flotsam on my camera. If I were doing this for an actual image where I were stacking and processing, I would use things called lights and darks, and well, actually they're called flats and darks, and then I'd use dark flats, which would process out all that nice dust motes and dust bunnies, and you'd see little O's and stuff like that sometimes. But yeah, with all the processing you do, you can tell it disregard these things that you see when you take a flat and it sees them. And all a flat is basically a light panel that you place over the top of your telescope, or in the. You basically stand your telescope up on its end, and you put a light panel on top of the dust shield, and take pictures with the light panel on. And by doing so, you actually can see the dust motes and stuff on the camera sensor, and it knows to disregard those when you incorporate that into your processing. And the darks are used for actually taking out hot pixels and such, imperfections in your sensor. So let's see, how are we doing online? Oh, looks like we're down to about 4 people. We just picked up 2 more. There was down to 2. So you people that are out there that are watching this on a Saturday night, thank you. It's the safe alternative to physically taking in a star party yourself.
yes. Almost there.
Hey, no worries. I'm just floored that I can get that object as nice as it is.
All right. So now I'm doing this
Wonder
direction.
if there's a nice let's see, Barnard's Galaxy. Let's see what that looks like in my sensor window. And that is NGC 6822. Oh, that's it's one of those galaxies that doesn't have any distinct form. It doesn't have any the nice little
It's irregular?
bars. It's an irregular, yeah. Let's see, fireworks, NGC 6946.
All right, now spinning over to Formulet.
Yeah, that's a
I
small
did
one.
the alignment yesterday, and it should have stuck, but apparently it didn't. So that's okay. It is getting
Triangular.
chilly.
Oh, that's a good one to get. Let me try that one. Yeah, the neat thing about this is that you can actually do everything about your camera or your field of view. You can adjust to make it so that you can see what it'll look like once you have it imaging. So this is Triangulum M33. Let's see where that's at in the grand scape of things in the sky. So we'll stop that.
I have to admit, I do like this mount a lot better than the CGEM DX.
I can't complain about any of the mounts that I've seen. The CGM was nice if you hypertuned it,
I did.
but even then it was
No, it was loud.
heavy and
Oh yeah. I was actually going to bring it up this weekend, and then I decided, why?
yeah. What up? M33. Let's look at that. There it is. Hey, it's actually up. Let's slew over to it. Yeah, I'm starting to feel the cool air myself now.
Yep.
It's
Right when I'm almost ready.
let's count the chirps. Oh, goodness.
Wrong direction.
Yeah, they must be behind on the weather or the weather app I use on here because it says it's 71. Let me see if it.
Not in front of the crickets here. Well, it depends. Are you doing it in town or are you doing it
I
out
just
here
have
in the middle of
grand view.
nowhere?
I don't know if it's specific to here or not. I can tell you it's 76 degrees back home. uh,
Come on. Get in the center. Just got to get one more thing right in the center.
oh, it's 64.
Ah. There it goes.
So there you go, all you weather aficionados. It is getting colder.
Yep. What's not fun is I was hoping to get in the pool tomorrow.
You're going to get in a pool tomorrow?
Yep. It's hoping.
I guess it'll be warmer in the day.
Yeah, we have a cover on it, so it's all right. Altitude misalignment.
Wow.
West.
That's a bit of a fainter object. Almost looks like a nebula, but I don't know that that's the case. It's pointing away from us, so.
All right. Let's see how close I can get to stuff. Let's go back to Deneb. If not, if I'm not able to really get, which one is this? This isn't Helix, is it?
This is M33.
M33, which is
the Triangulum.
Oh,
Galaxy.
okay.
It should fill up the sensor. It should look really nice and big.
Once it does the
once it stacks a couple,
okay.
You should see it. I might have to bop it up to 180 on the timing.
All right. What's the Helix? The M number?
Helix is, let me see. It is NGC 7293.
7293. Okay. I'll look it up.
Yeah, you should pull it up really big on yours.
Yeah. If I can find it. Okay, cool. It's close. It's close.
Hey, as long as it's in the field of view, you're doing good.
Well, no, yeah. I'm looking at Deneb right now, so it's better than what it was. All right, back. Let's look at the ring first. Menu. Select and slew. Deep sky objects. Messier. M57.
Oh, there it goes. Now it's starting to define. You
Yep.
can see the
Oh,
arms
yeah.
and the swirl in it
You
now.
see a little bit of structure there.
Hmm?
You can see some structure there.
Slowly but surely.
Yep.
Yeah, this is what they call EAA, electronically assisted astronomy, which basically is good for doing outreach or uh, just going out and enjoying, just some objects. You don't want to go out there and take pictures all night long, but you want to spend some time looking at objects in the sky and
Yep.
share it with your family and stuff like that.
It's simple, it's straightforward.
Yeah. There's some telescopes on the market that actually they market to people that don't want to do anything but just look at objects, and they do what this is doing here, only they're more automated, and you can do it from a tablet where you can basically just hold it and watch the objects come through on your screen.
All right, I've got it on my finder. It's not in the center of my field of view. On yeah, I just have such a small field of view.
Yeah, well, I mean that's a big focal length.
Yeah,
It's not tiny, but you should be able to bring it closer to the center. Excuse me.
Yeah, I'm gonna stop. I'll just keep doing this. Ping. I mean, I can literally see where it is in my finder, but my finder.
Yeah, on your screen, you're seeing the central object in roughly the center of the picture, and then if you can see it, if you see enough
Yep.
detail on there,
Wow.
around the outer bands
Got
or around the outer portions of the picture, there are some more of the galaxy that are just starting to appear.
All right.
What you're roughly looking for is this. I can put up here. Let's see where we at. Right there. So what you're roughly looking at is that this little area, the brightest area portion of this picture on Telescopius is what we're looking at right now. And as we take more and more pictures, you'll start seeing the outer bands up here. And that'll be in this area here. And this is basically, we're looking at how many pictures? Looks like 3. We'll hit 4 here. 4 2-minute exposures. That's not too bad.
Yeah.
And just realize we've got lights sitting here on us so that you can see us on the cameras, but if we were in a little bit darker situation, this would be a little bit more defined.
And these lights they're not terribly bright right now.
Yeah. You
But
wouldn't do visual under these lights, let's
No.
put it that way.
no.
Yeah, camera's the only way you can get away with doing lights like this.
All right. So it is right now. I'm recalibrating guiding because of where it is, where it's pointed. But I actually did manage to center the ring. So as soon as the guiding is or the calibration is done, I'm going to do another exposure. I did a minute exposure. I could see it, but it wasn't in focus. So we'll get it. This is what a lot of this astronomy is. It's sitting around and waiting.
It's like IT. Hurry up and wait.
Yep. And that's what we do. We just sit around and wait. Usually, if it was going to be this cold, we would actually wear something more. It's I just didn't think about it.
As a cub master or a former cub master, I can tell you that one time I went camping with a group of us in the fall, and I forgot to bring anything but what I had on, which was a pair of shorts, a t-shirt, and some
That's not good.
socks and shoes. And I survived the night, and it got down into the 50s. Let's put it this way: I had a very warm sleeping bag and was not very willing to get out of it in the morning.
All right, this one is
4. We're going on 5, and
guiding.
from my point of view, I can see that the bands are starting to appear more and more distinct on the outer edges of the galaxy.
Yep, you can see that from here as well.
Good.
George, you're not exactly centered in the camera.
No, I'm not. It's not perfect, but it is what it is.
No, I mean you are not centered.
Oh, I'm not. Oh well.
You're off on the edge.
That's probably for the best.
I'm in the got 30 seconds left on my exposure of the ring. Let's see just how big it can get.
Well, that'll be pretty.
Guiding, we'll see. We'll see how much in focus it is too.
That's true.
Oh, Batinov mask. So what I used, I did the collimation for it. I made a Duncan mask.
Right.
And what a Duncan mask is, it's got a hole in the middle for the secondary mirror.
Right.
So it fits over tight. And then you do these cutouts, 3 cutouts at 0, 120, and 240 degrees. And each of them are, at least for this one, I think each cutout was about 3 inches wide, and it went in about 1/3 of the diameter. Oh, I need a much longer exposure. It's barely visible there. Yeah, I'll do
Yeah, you should look into the Tri-Batnoff.
well with this one, what it lets me do is it lets me collimate.
Mm-hmm.
And when you look at it, you see these 3 big spikes, okay, as you're coming in and out of focus. And what you want to do is you want to move the screws for the secondary so that those 3 spikes are all symmetrical. Once they're symmetrical, it's collimated. And that's all you have to do.
Very nice.
Really straightforward.
Yeah, they keep coming out with new ways of doing things.
Well,
Which is good.
This one, it was Duncan, whoever it was. This was done, I think it's like a 15 or 20-year-old design. It's not really terribly recent,
Right.
but it works out pretty well. I just made out of cardboard and plopped it on there. Excuse me. And that was enough. And I've seen the Tri-Batinovs and calibrating or collimating using a Batinov, and it's like, this is complicated. So I used one of my Astro cameras on the back of the scope and used SharpCat Pro in order to, and the bullseye, so I could see if it was symmetrical or not. And I just kept playing with it until I got it right. So with the Duncan mask, it helps with the Schmidt-Cassegrain. With the Ritchie Chrétien, it took a little bit longer.
Mm-hmm.
And what I ended up doing is I have a one of those what do you call them? I won't say an endoscope, but it's not. It's a USB camera on a long cable, and it's got a little tiny head on it. And I was able to use that and stick it inside the telescope, face it the opposite direction, so I could see exactly the laser hitting the center spot on the secondary. So then once I knew the secondary was properly centered, I could send it right back to, or I could then work on the primary mirror. 1 second left.
You have somebody by the name of Barbara Winter
Oh, yes.
talking in a Language I think you're familiar with, but not me.
That would be my mother-in-law. It's morning, and yeah, it's morning over there. So I'm gonna switch it over to mine while yours is still going. We have the ring, and this is at 100%. Not 100%. This is the entire chip. So let's go 200%, and it's this wispy thing. I don't think it's quite in focus. I'm pretty sure it's not exactly in focus because, no, batting off. Yeah, it's a little bit off. But it is there. It is the ring, and we see some color. So it's got a little bit of blues. You can see the reds out here for probably hydrogen and sulfur, and the blues for oxygen. Not terribly bad. Not great, but not bad. And we can see the white dwarf right in the middle. So I think it just needs a lot more focus. I probably need to fix the calibrating or the collimation. What was that?
No idea.
Oh, it's probably one of the barrels clanking because
Temperature?
it's changing temperature. Yeah. It's now colder than 67 because the crickets have slowed down a little bit. Yeah, it's earlier we were figuring out how cold it is from the crickets. So count the number of chirps in 14 seconds and add 40. Let's try it again. Got my countdown. So ready and
We'll be in 576.
26 plus 40 is
66.
66. So it 65, 66, somewhere about there. Yeah, I didn't bring a jacket or long pants. I have socks. I was just going to come in sandals, but I'm glad I took socks. So here we go. We have the Ring Nebula. It's quite big in here, but the focus isn't quite there. I just didn't put a Batinov mask. I just left it at home. So without the Batinov mask, it's hard to get a really good focus on here. Like manually focus it in. And I do not have an autofocuser. I have the electronic focuser, but I don't have autofocuser software set up on here. So it is what it is. How's your galaxy coming in?
I stopped doing it and just, I was going to look at something else, but
What else do we have that's good right now?
let's see.
Something nice. We can find something. There's Pluto, which we're never going to be able to pick out. And I remember, well, Pluto's also still close to the Milky Way. So, oh, Uranus is up. Uranus. Let's see if we can grab Uranus. So we're going to stop the auto guiding and instead go to, let's see how close we're going to get. Menu.
Yeah, I have to replace one of my fans in my computer here.
Oh.
Fun times. Okay, let's see if we can get something out of that. Yeah, that came out pretty good.
Yep.
NGC 7000.
North American?
Ooh. Look at all that.
Where?
It shows all the satellites.
I don't. What? I can't see.
Oh, on my, you can't see the satellites on the picture?
Not. I'm still looking at Galaxy
Okay.
on your side.
Well, I just switched over to it. I don't know what it did, but it basically, I guess, it had to do something, but it's, oh wow. I mean, it shows the galaxy in the center, but
Okay.
it shows all the satellite trails it must have taken out.
Oh. Oh. Okay. Yeah, there's.
I mean, there's dozens of them. It's almost freakish.
Yeah. There's Uranus. All right. We're not gonna do. Let's see. Now we're looking at Uranus.
Not the right color?
Yep. Pale blue. Really obvious.
Oh, nice.
So I'm gonna get it here, and then I'm going to get it a little bit closer to the center and get a longer exposure because I want to see if we can pick out the moons. There we go. All right. I'm gonna bring it up here.
You think you'll be able to get the moons?
Oh yeah. Uranus, easy. Oh yeah, yeah. I'm not worried about that. Not all of them.
Well, there's quite a few small ones. So.
Yeah, but the close-in ones.
Yeah.
Yeah, we should be able to pick those out. All right, next. So all we need is a. There we go. So now we have a bluish, green kind of color, and we're gonna do. This is a 2-setting exposure. We're gonna do. Let's do a 16-second. Well, let's do 8 seconds first. See what 8 seconds does.
A lot of satellites.
I'm not picking anything out yet. 8 seconds. Do we see anything around? Nothing yet. I don't see anything yet. There should be stuff right around there. Let's go 16 seconds. A little bit longer.
You're probably going to have to overexpose to get the moons.
Oh, yeah. Yeah, it's going to be blown way out, which is fine.
Which one is the planet that actually is rotating counter to the axis of its orbit?
Venus?
That's the one? Okay.
Yep. Barely. And then Uranus is on its side.
Yeah.
I think it's my focus. My focus is off, so I'm not able to see. I'm going to try a 30-second exposure, 32-second exposure. Because I've seen, when my focus is really good, we've seen moons of Uranus very, very easily. But I think my focus is off. If my focus is off, then I'm not going to be able to see these very well. Unless, maybe if I punch the histogram up a lot. A little bit more. One more second. Let me punch the histogram. Maybe. Oh yeah, there we go. Yep. It's out of focus. That's what it is.
Well, as the temperature goes down, it's going to be.
Yep. That too.
More and more needed focus-wise. I haven't done a refocus on mine's carbon fiber, so
yeah,
doesn't seem to affect it.
So we've got some moons. Miranda. Nope. I don't know. I can't tell which ones they are. Just because scale is weird. But yeah, these are some of the moons of Uranus. 1, 2, 3, 4 at least. I'll pick out more, but honestly, it's like just getting them is a pain because they're out of focus. So if I drop my focus down, or not focus, if I drop that down, I see a star. Yeah.
What's neat to watch is if you get a star that occults the planet.
You mean a planet
Those
that
are
occults
neat.
a star? Planet's closer. Yep. Come on, give me better.
It's a reminder to myself I have to put in my hours on my volunteer time.
Yeah, I keep forgetting to do that.
I should be able to get the required number of hours so we can get a nice little something in the mail.
Push that.
Wow, it's coming through pretty good.
Yeah.
I can see partial Cygnus wall.
I'm still not able to. I can see the moons. It's just getting the focus. And without the Batinov mask, it's just. Maybe a little bit better.
Hmm.
Maybe a little bit better. And also, this has this focus motor controls the primary mirror, so
Yeah.
there's some mirror flop involved.
Mirror floppage.
Yeah, especially with the scope.
It's one of the reasons I went to a refractor instead of a continuing on reflector.
Yeah.
If I were doing a reflector at this point, I think I would go for a RC.
Yep. I like my RC. That's why I dual mount it with the TeleView 101.
Yeah.
I just thought, well, I deforked this. I'm going to try it because this one's better, or this mount is better than the fork.
Yeah. If Celestron would put their focusing technology, the one they have in the RASA version 2,
oh,
it would be rock solid. Right now, it's still got the mirror flop.
That's why
People
everybody.
are having to make do by locking the mirrors on the new systems and putting in Crayford focusers. It's
Yep.
like you pay all that money. Why would you have to do that?
Because you have to.
You're just turning it into an RC
Yeah.
with a
pretty much.
corrector plate.
Yeah. I haven't been able to use any of those. I've seen them, and they look really nice.
Yeah.
But yeah, it's still. I shoestring everything as much as I can. I've just always done that. Everything is bought used. Everything is. Yeah, it's spend as little as possible, just to get something done. And honestly, it's hurt me in a lot of ways.
I
And
think the best thing you did was get that mount.
this one, yeah, because I borrowed I borrowed Keith's, and because the motor on the CGM DX died,
Mhm.
and when it did, it's like, well, I can't do anything with it now. And it took me a while to get that motor too,
Oh yeah.
just to find it. So once I did, great, I was able to actually put it together and use it again. Okay, so what are we looking at? Titania, Umbriel, Ariel, and what's the far side one? Oberon. Ah, jeez. That's what I think we're looking at. And it'd be great if I could please, just don't do this now. Don't do this now. I have to center it out again. Okay. I think that's what we're looking at on here, but I've got to get a little bit more focus. I don't know. It's I'm
Stack.
punching up the gain a lot with the histogram. I just want to get those moons as tight as possible. One more exposure, and I think that's about as tight as they can get. So we're exposing heavily. We're pushing the histogram, so we're pulling them out of the muck. But that's essentially what we're doing is just pulling it out of the muck. I went too far in the focus. Yeah, I think that was better right there. But again, without the Batinov mask, it's really hard to tell. And oh, I forgot to turn my cooler on.
That'll make it noisy.
Cooler is off. Cooler is on.
Oh, so you switched over from your DSLR to the...
Ages ago.
Oh, okay.
All right, what's it doing now? Now it's going. Now temperature's dropping. No wonder it's so noisy.
That'll do it.
Yeah. So, yeah. So astronomical cameras have coolers on them. Um, it's called a Peltier cooler or a thermoelectric couple, and what it means it's got two sides, and a semiconductor on the inside. So two ceramic plates, and when you push electricity through it in one direction, one side gets very very cold, the side gets very very hot. Uh, the cold side can get cold enough that it will frost over very very quickly. The hot side, if you're not careful, will burn out. So you got to put a big old heat sink on the other side. Um, so these astronomical cameras have the cold side attached to the back of the imaging chip, then heat sinks and fans on the warm side, so air blows over that and cools the hot side down so it doesn't cause the chip to burn out. Yep. So we're looking at Uranus's moons. So in order, we have from left to right, we have Titania, Umbriel, Ariel, and Oberon out here. And there's some more. Miranda's right about there. It's just, again, hard to pull out right now. Not quite in focus, but all right. So Edward is asking, can you guys tell us about the first time you fell in love with astronomy and how old you were when you found your first astronomical features that you said were cool and memorable? Want to take it, George?
Let's see. I was 17 years old. We had just moved to Texas from Indiana. My father was in the Air Force, so I'm an Air Force brat. But yeah, I saw he had gotten a job at General Dynamics, and General Dynamics at the time had a dedicated astronomy location, dark sky site. And because I was a dependent, I could join their astronomy club. And I went out to several of their meetings and was able to look through telescopes and such. And what I found was my first object was Saturn with the rings and the Cassini gap and all that fun stuff. And that caused me to go to several of their presentations at their location. And one of them was put on by a guy that I guess the Big Bang Theory cosmology, and he gave a talk about the Big Bang Theory, and it's like it was one of those mind-blowing moments when you kind of thought, wow, and that got me hooked. And after that, I bought my first telescope and my film camera, and took it out and started doing imaging at night. And my guiding wasn't PhD. My guiding was crosshairs in a finder scope and two knobs on the actual mount itself that adjusted Altair and the deck. So it was all manual at that point in time. You actually, while taking a picture, had to adjust it to keep it in the crosshairs. But that was my first deal, age 17, and I haven't looked back since. I've been doing it off and on over the course of my lifetime, and just now got to the point where things have gotten really interesting in the hobby as far as astrophotography and the stuff I love to do, and I keep going on, keep trying to better myself by doing more and more in the field.
Ooh, well,
Your turn, Chris.
I've I don't know. I remember I checked out all the books at the library on astronomy at one point, and the librarian wasn't terribly happy because I didn't leave any books for any other kids. It was like a big old stack. I got my first telescope. I was 19 or so, and because my parents didn't buy me one, I bought it for myself, and I very quickly learned that a 4.5-inch newt on a flimsy mount is not the way to go. It will not. You can't hack the thing to take good photographs. It just won't work.
You're doing landscape photography, by the way.
nuts. So instead, I went and I took a course at TCC at Tarrant County College, and there was um, Tim Black was actually doing a course on how to build a telescope, and so I took the John Dobson basic design and I looked at it. It's like, well, this kind of sucks. And I put on a real focuser and a real spider with a secondary mirror. And Tim got very upset and he said, "You can do whatever you want, but I can't afford to spend any time helping you fix your stuff because I've got all these other people I've got to worry about," which is fine. So I fixed my stuff, and my stuff was fine. Mine worked, and we did a star party. This was the Fort Worth Sidewalk Astronomers. So I started that way, and that was a great telescope. It is still in my garage. I will convert it eventually to a truss design, but we designed or we built a truss telescope after that. So a friend of mine contacted me and said, "Hey, I know you build telescopes. I've got a coworker who has cancer, and it's terminal, and we want to get him a telescope for like so he can share it with his kids." And I was like, "Okay, yeah." So I had been working on a design, and my father and I actually finished designing it and building it out in about 2 weeks. And on the third weekend, drove down to Austin to deliver it. And it was an 8-inch truss telescope, a Dobsonian, but it all folded down into a little box with the poles on the side. So from there, it was really neat, and I like doing it. So we built two more, modified the design so it worked a little bit better for us, and uh, built those two telescopes. And thought, you know what, we could build a company out of this. Yeah, we never had time to do that because then I got married, and you got no time after you get married. You'd rather spend all your time with your wife than spending it in the garage building telescopes. So that's what happened. And those two telescopes, one of them is in my uh, is in our library, I guess you can call it. It's where the books are, and the other one is hidden away in the closet where no one can break it, because that one has a very special mirror from that was made by Alika Herring in the 1970s. And Alika Herring was this fantastic mirror maker from Cave Telescopes in California. And Alika Herring was the guy who discovered that Mauna Kea is one of the best places, and he said it was the best place in the world to do astronomy. It's very, very high up, very, very cold air, and very thin air, and the views from up there are just fantastic. Now we have Mauna Kea, we have the Atacama Desert in Chile. Both places are very, very similar. They're high altitude, they're very cold, they're very dry, and you don't typically have clouds there. So that's why they're good places for astronomy. Uh, but Alika Herring actually spent time up there on Mauna Kea in the cold on moonless nights drawing maps of the moon. And from his maps of the moon, uh, NASA decided where to send the Apollo missions. So it's a very special mirror, and it's a fantastic mirror. I just don't take it out because it's kind of one of those things where it's an antique, and um, it's like having a very old antique sports car with a couple hundred miles on it. You don't really want to take it out because the more miles you put on it, the more you risk having an accident or something happening. So just don't do that. And it's in there. But I've just always been interested in astronomy since I was a little kid, and now it's neat that I can do stuff like this. That I honestly, 10 years ago, I didn't think I wasn't thinking anything like this. What was that? Cat?
Oh, me.
Your telescope meows?
No, that was me making that noise.
Oh.
I make noises. What can I say?
All right. I don't know about you, but it is after midnight. It is getting late.
And cold.
And it is cold. It's in the 60s. I still have 2 hours of packing.
I bet we can get that down in
Not the 15 minutes we're not. So it's all right. How we got this? George, are you packing up already? So it is quite cold. You want to say goodbye, George? Sit down.
Good idea.
All right. Oops.
Goodbye, George.
Oh, hang on. There we go.
I'll sit back down.
Yeah, sit back down. Both cameras are on.
Oh.
It is late. It is now 12:14. I'm pretty sure that the star party at Tandy Hills is over.
Several hours ago.
Probably. We're just masochists here, dragging it on as long as possible. But it is cold.
We're shivering.
Yeah, I just want to go home. That's pretty much it. I just want to go home now.
We love astronomy, but not that much.
Yeah, there's a point where we're not dressed for it for the season. We're not dressed for summer in Texas, apparently. And so it's time to pack up. It's time to go home. We've seen some neat stuff. We've seen galaxies. We've seen nebulas. We've gone through the planets that are visible. We've seen Venus, the moon, Jupiter, Saturn, Neptune, and Uranus. Ring Nebula, the Helix Galaxy. Had some equipment issues. Started late because I didn't pay attention. And yeah. Time to call it a night. 12:16. I'm done. You done, George?
I think I'm done.
Okay, cool. Thank you very much, everyone, for joining us, spending time with us on your Saturday night. Have a good night. Let's all go home to our nice warm beds. Except the people on the other side of the planet who are just now waking up. Get to work. And good night.